All right, awesome. Well, we are really excited to be doing this workshop today. Thank you everyone who's able to join us. This workshop is titled Build Your Identity Solution Using Hyperledger Aries. We're excited to have a great group of moderators and instructors today. We are excited to talk about the Hyperledger projects that have made production level decentralized identity solutions possible in various use cases across the globe. For introduction, my name is James Schulte, and I do business development here at Indicio. And I personally help companies from around the world and from various industries learn about Hyperledger Aries and Indy and how they can be used to solve complex business and social challenges using decentralized identity, which is oftentimes referred to as self-sovereign identity or SSI. I'm sure you've heard a mix of those three terms. There's a couple other terms for it as well, and today you might hear a mix as well. But this technology is an open source protocol that enables these technologies to work. The work that the open source community is doing with these projects is playing an important role as more and more enterprises and governments move towards decentralized identity models. And today we're lucky to be joined by some of the world's leading digital identity engineers who specialize in these protocols. And you'll get a firsthand walkthrough on how you can use these tools to build your own decentralized identity solutions. As mentioned a few minutes ago, in terms of technical support and questions you have throughout the workshop, you can drop your questions in the Aries channel on the Hyperledger chat. I think it was previously called the Hyperledger Rocket chat. Drop your questions there. We have multiple Indicio team members who are watching the channels there, and we'll get to you as soon as possible. If for some reason we're not able to answer your questions, then the questions will remain there on the channel, and we'll come back to as soon as possible to help you as you work on your own projects. As I said prior to today's workshop, you should have received a set of prerequisites or instructions to get your machine set up to participate in the hands-on portions of the workshop. If you've not done this, don't worry. We're happy to have you here, and feel free to follow along and watch as our instructors do the demonstrations. And as mentioned, today's recorded session is going to be available on the Hyperledger Foundation's website, along with the instructions and links to all of today's materials. So feel free to go back and access that at your leisure. So we hope that today is a valuable resource to your team as you work on your digital identity solutions. And with that, I will hand off to Scott Harris, who will be leading the first segment of today's workshop.
Thank you, James. Great preamble there to get us set up for a really productive and good day of education and discussion. My portion of the program here is called What is Decentralized Identity? It's sort of a why are we here doing this in the very big picture sense. For those of you that are maybe newer to the space, this should provide the sort of philosophical groundwork that says, why does this technology even exist? Why was it created? And what are the values that are going to be derived from it? If you've been in the space or circling around it a little bit longer, it may be a bit of a review, but I think it's good to have a leveling of the playing field here before Len and Daniel, Shar, and Sam get into the technical content. So it'll give some context to everything that they're saying and talking about today. My name is Scott Harris. I'm the VP of Business Operations at Indicio. I wear a lot of hats. As you can see by my profile picture, I'm probably the kind of guy that likes hats. One of my roles, in addition to helping Indicio work effectively internally, both between our work groups and with our clients, is to do some problem solving in the use case side of things. So I work with our clients to help articulate the application of this type of technology and help them derive some business value very quickly out of this. And we've been quite happy with how that's turned out. So without any further introduction, here's some background. Why are we here? The internet and identity. This is a very old cartoon, I think from the New Yorker a long time ago, and it's still applicable today. And the truth is the internet was created without a way of identifying Who's on the other side of that computer or that device? And in some cases, in many cases, anonymity is desirable. It does help protect our privacy. But I'm sure we're all aware of the ways that anonymity can be quite dangerous and also quite difficult for businesses to execute some of their functionality if they don't know who's on the other end of the line or who's communicating with them. And we'll talk about that on the next slide. The main reason we have identity systems at all, usernames, passwords, things like that, is to establish some sort of trust. The trust that we establish, however, only goes as far as the work that's put in at the entry point to that trusted ecosystem. So if we have a LinkedIn account and you've signed up with an email, well, anybody can sign up with an email and pretend to be anybody else they want. If you say, okay, I'm using my email to sign up for LinkedIn for my Gmail account, the question I would ask is, what did you do to get that Gmail address? And the answer, of course, is absolutely nothing. If you're like me, you probably have 10 to 15 email addresses floating around for various purposes. And again, that can be great to help preserve some of your privacy and protect some of your information. But when it comes to identifying who you are, some attribute about yourself, it's very untrustworthy and not useful. So we need something better. To talk a bit about our terminology, we've already said the word identity probably 20 to 30 times today. So I think it's worth looking at what we mean by the word identity. It comes from a lot of different sources. This is sort of how the world looks today, that your identity comes from a pie, if you will, where a portion of it is generated and often held by these entities that give you some of this identity. What we really mean by the word identity goes beyond what your common definition might be, which would be your name, your address, your date of birth, eye color, height, weight, those sorts of things, to broaden out to be defined as a set of data that refers to a particular data subject. So a little bit of that is GDPR language, the data subject, but we'll talk, or the rest of our group will talk today quite a bit about an identity holder as a data subject and refer to that as a person, but it doesn't have to be a person. When you think about it, devices and IoT things have identities that are issued to them. Business enterprises have identities of their own. So everything that has any digital footprint has an identity in that regard, and it doesn't necessarily need to be the traditional definition of identity. The problem with identity right now is that it's largely centralized. And what we mean by centralized is that data is controlled and shared and handled primarily by third parties. Your digital identity is very difficult to control. Of course, we know everywhere you go, digitally, there's data that follows you along that you generate by virtue of a relationship, and that data is not within your control. And we can't completely solve for that, but we can solve for some of the problems that are derived from that. And those problems are consent and compliance and transparency. So when we look at the centralized model, it kind of looks like this, where let's say a government might give you a traditional kind of ID, such as a driver's license. And often those, the digital versions of those sorts of things are shared between entities and outside of your control. Decentralization looks a bit more like this, and it's an oversimplification, really, of what we mean by this decentralization, but I think that's a good thing because a nice simple picture helps us wrap our heads around what we're after. The decentralization breaks apart those relationships, but puts the identity holder, in this case a person, at the center of things. And there's a bit of contradictory language there, where we think of a person at the center of their identity, but call it decentralization. So of course we mean decentralization in with the technical definition. But when we break apart those relationships and keep those entities from sharing data behind our back without our consent, it may or may not be a good thing. In some cases, we may give up some efficiencies in order to maintain privacy. And of course, privacy protection and efficiency are two of the things we're after. But this picture here with the pie pieces broken apart is really just a digital model of the analog world, where an entity may give you some piece of your identity, whether it's a government or a workplace. Imagine logging into your employer's website and your HR portal and downloading a tax record or a pay stub from your employer. That pay stub constitutes part of your identity that was given to you by your employer. And if you go to apply for a mortgage, you would download that and you would send it out to the mortgage company. So in the old world, the analog world, you would probably print it out and then mail it to them. And now we're trying to do it digitally. So our goal here is to create a digital model of the analog world where you have some control of that. Imagine walking in with your driver's license here to buy an age-restricted item, and you don't hand them your driver's license and let them make a copy of it and say, hey, take it, keep it, do whatever you want with it, don't worry about it. But in the digital world, that is effectively what we're doing with our complete footprint as we go about our interactions and our online relationships. So we want to go and try to replicate as best we can the control that you have in the analog world. So with that, a very brief history lesson on trust and where we've come from and where we are now and where we're headed. In the analog world that I'm speaking of, and I'll throw some dates out there of about 3200 BC when the first writing was recorded that we know of, to roughly 1964, we had a system where it was really easy to trust physical documents because they had some indicator, visual or tactile, of whether a document was authentic. So we have notary stamps and raised seals and special paper and envelopes that are sealed or wax on them, registered mail. We have a lot of ways when you receive a physical document of saying, hey, is this authentic? Do I know where it came from? Can I trust it? But of course, that's really inefficient. And we don't like inefficiency here in our modern digital world. With that, we also had a lot of privacy and control. So not the greatest system. In our hybrid world, the one we're kind of living in today, we've sacrificed quite a bit of trust to gain a little bit of efficiency. So now what we're doing with those physical documents is we're snapping a picture of them with our phone, and now we're sending a JPEG instead of the real document, or we're scanning something, faxing something, and we're gaining some efficiency. But of course, what we're really sending along to that next party is just a digital representation of the document and not the document itself, and it's not trustworthy. And of course, as I described, once it's given over, our ability to control it is minimal. So we sacrifice quite a bit of privacy there. I recently went through a mortgage process and had to email a bunch of things to the mortgage lender, and it darn near gave me a heart attack thinking of all the opportunities for the loss of privacy there. But of course, I did it because there's really no other way that's reasonably efficient. So in the decentralized world, as we build out some of these tools that you're going to see and hear and learn about today, we should be able to gain back almost all of that trust and all of the efficiency and maintain our privacy. So why does that analog model work? Well, as I said, we have ways of verifying what attributes come to you if you're the one receiving some information. And it works because the person receiving it has visual and tactile ways of determining whether that driver's license is real. There's a hologram and it's fully laminated and you haven't cut into it with an X-Acto knife, that sort of thing. And right now, the representations that we send along as representations of an identity piece, of course, have those risks and costs associated with it. And that's a big reason why we're here today, is that the business world has recognized that there's a massive cost to fraud, to losses and hacks and things like that. Imagine, you're trying to verify who someone is, and I did it this morning, where let me verify your email and send you a 2FA prompt. And of course, we all know that no one's ever given over control of their email address to somebody else. So it's really only as good as the actual system that you're using. What we're after here is trust in the data, trust that we don't have. And trust comes in two forms. It comes in the form of integrity, which is being able to identify if the data is real, or in other words, has it arrived to you as it was created and issued by that issuer? And another way of saying it, has it been altered or tampered with? Again, the analog documents have some really nice ways of identifying whether someone has put whiteout over the page to change their birth date. So we want to get to be able to verify data integrity. We also want to verify authenticity, and authenticity means, can I trace it back to its source? Do I know where it came from? And if you have those two things, you can trust the data. Now, whether you execute a business decision based on that trust is really up to you as the person receiving it. But at least you can know that it is real, it's unaltered, and if it comes from a source you can trust, you might let that person who's sharing it with you go further along in your business processes. Behind that trust is something we refer to as governance, and that can be, I could talk 4 hours on governance just alone, but we won't do that today. A couple of quick slides. Governance comes in two layers that helps us trust that data. At the bottom, this is a lot of what you'll talk about today, is the cryptographic trust, which begins with Hyperledger products and the DIDCOM protocols that help them along. And then there's the human trust, which is contractual agreements and the legal framework that says, hey, we're going to issue a credential and let someone take possession of it, and then here's a way we can present it. In another view, I like to refer to it as cryptographic trust, all of the things we're going to talk about today, and then philosophical trust, which is really just a business decision. Participants in this trusted ecosystem are usually placed in this sort of triangular relationship where we have an issuer of a credential here on the left who gives some data about this data subject, so their identity in some form or another, to a credential holder who then takes control of that, just as you would in your analog wallet. And when asked or requested for some data by a verifier, shares that with consent and transparency. So we have issuers, holders, and verifiers, and then we have the verifiable data registry or ledger, and the networks that support that type of data exchange. No more on that from me, because smarter people than I will tell you about that part of it. The nice thing about this from a privacy point of view, remember we want to maximize trust and privacy and efficiency, is that the PII type of things, when we're speaking of humans as credential holders, stays with the data's owner or the authorized controller of that data. If you're not talking PII per se about a person, if you're a business enterprise and you have an identity and you're exchanging information this way, it allows you to maintain control of sensitive business information as well. The ledger that will constitute the bulk of our content today, pardon me, is just the means of verifying those two things I already described: authenticity and integrity of the data. So the data itself stays up here kind of above the line, from the issuer to the holder and given to the verifier. The question, to trust or not to trust, is really not ours to make in the context of what we're talking about today. The verifier who receives that data can trust that it is authentic and has integrity, but whether or not they trust the issuer is up to them. And a very simplistic example would be if I were to share, let's say, a driver's license to buy an age-restricted product, the verifier who's selling me that product can verify that, yes, it has integrity. I haven't changed my birth date, and it came from the Motor Vehicle Association. Okay, so now it's got integrity and authenticity, and they can do the head scratch and say, I really trust that Motor Vehicle Association, so I'll let you buy that product. However, if I was issued and held and presented as proof of age a Dunkin' Donuts or Starbucks driver's license, the verifier can still say, yeah, you haven't tampered with it. And yes, it's authentic. It did come from Dunkin' Donuts, but no, we're not going to trust that as proof of your age, because we don't trust them as a source of your age. So to trust or not to trust is really a business decision in the end. Some quick use case examples to help tie what I've just said to the real world. In the case of issuers, we can think of, let's say, a government agency or entity that wants to issue you a credential that says, hey, you live here within the scope of my domain here. And the first thing the government might ask you to do is to validate your identity, either using a mobile app or even by showing up in person and saying, hey, here I am, and here's my driver's license. And if they do that, you can see where they need that analog assurance of who you are. However, once they've validated your identity, they can take some more information from a holder's wallet or application and give you a government credential. In this case, we'll call it a government residency credential that says, hey, you do live here, we know who you are, and we've got you in our database that we already have permission to have you in from you. And we're going to give you this residency credential. So now you might go to a bank and go to their bank website and scan a QR code and present your government residency credential as proof of who you are and those data attributes that refer to you, the data subject, and that have been given to you by the government as an issuer. And the bank can say, okay, let's request some of that data. You share it with transparency, you share it with consent. You have to take some discrete action often within the context of an application in your mobile device or in a cloud-based interface where you say, I consent to giving you this data. And then the bank says, hey, we can verify it. We can go and check that it has integrity, and we can check the source, and it is authentically from the government, and therefore you can open your account right now in 10 seconds rather than having to come in and show your ID and show your face and all that sort of thing. Once that trusted data is received by the bank and you've given them permission to have it and hold it and use it, they can use it to issue you a derivative credential, perhaps, that says, hey, here's your bank account holder's credential. It's in your device, and we're going to let you log into your account now using this, or we're going to let you transfer funds using this, or open a second account using this, because we know who you are and we have been able to delegate that trust from its original source. So before we get into the bulk of the content here, a couple of notes on the roles and the conventions and some of the language we'll use. The code architecture that we're going to talk deeply about, of course, centers around the Hyperledger products here, Ursa, Indy, and Aries. So you'll hear those words repeatedly. I'm sure you're familiar with those. We have some basic building blocks that go with the real world execution of this. So we'll have cloud agents. That's a lot of what Daniel and Shar are going to talk to you about. Lynn is going to talk to you about the Indy layer of it here. And we have edge agents, mobile devices, laptops, things like that, and mediator agents. And if you're not familiar with all of that terminology, my goal here was simply to throw those words out so that you may not be hearing from them for the very first time as you go through the more detailed presentations. I've spoken about issuers, holders, and verifiers, and those names will be used repeatedly. So an issuer is a creator of a verifiable credential given to a credential holder, the data subject or data owner, and then shared with someone who wants that data, a verifier. So issuers, holders, and verifiers are throughout our day today. And again, I will fix that real quick for you. We also use some real world names, Bob and Alice. That's sort of it's not new to the identity community or unique to it. Bob and Alice are thrown around in a lot of other use case examples, but you will see Bob and Alice repeatedly here, sometimes as issuers and sometimes as verifiers. They're not exclusive roles, often roles overlap. So an issuer may actually give a credential to a credential holder, and then Bob acts as a verifier of his own credential. Likewise, And I apologize, I didn't do a good slide review there. Alice may also act as a verifier of her own credential, or take Bob's credential and then reissue from it. Very brief note on value. When we achieve the decentralized model that you saw earlier, trust, efficiency, and privacy, we are able to protect the data of individuals and be very compliant with things like GDPR, HIPAA, and those types of regulations. We use zero-knowledge methods and help businesses ensure compliance, in addition to making it efficient for all of their customers and end users. And so with that, we've got a very broad basis in why we're here. And up next for you is our presentation on Hyperledger Indy Networks by Lynn Bendixson. And I will let Lynn do his own introduction. And if you're ready, I'm going to stop my screen share and turn it over to Lynn.
Excellent, thanks, Scott. Just a few housekeeping items here before I get started. There will be a 5-minute break after I'm finished with my 20-minute or so session here, or portion of our training today. And I just call your attention to the handout here. I'll put a link again in the chat because we'll be using this during mine, copying stuff from here, or you can go to some of the links that I'll be referring to. So if everyone can have their screen ready for the Indy CLI hands-on part of mine later in my presentation here, that'd be great. Time to get ready for the hands-on part. So into my slides. So I'm going to have my slides looking like this, a little bit funny for you because I need to go back and forth and click on links and stuff for mine as part of the hands-on stuff. So apologies if it looks a little weird compared to how nice it looked for Scott's part of it. But I'm going to be talking about some of the tools. Scott gave you some of the background information. I'll be going a little deeper and telling you a little bit more about some of the tools. And I'm doing this because we want to share a little bit about some of the background, introduce some more terminology, and some of the other things. So before we get into the Aries part of it, just to give you an idea about how Indy works. So a little bit about me before we dig too deep into tools here. I am the Director of Network Operations at Indicio. This @Lynn Bendixson is my handle for every chat channel that I know about, I think. So you can get a hold of me there and ask me direct questions. I am I should say pending here, I think, because it's not quite 100% official. It's almost official. Be the co-chair in about 2 weeks of the TOIP Utility Foundry Working Group, along with 2 other excellent individuals. Utility Foundry means public utilities, so trust over IP. Wants to help people build networks through this working group, and I built a lot of networks. That's why I'm talking about some of these tools, is because I built networks and built network tools, and that's what I've been doing for several years now for both the Sovereign Foundation, helping to build their networks, and then also now for Indicio, I've built all of our networks for that. So that's my background and why I'm the expert that gets to talk to you about this stuff. So let's start with the developer tool. This one I didn't actually help write. This one was written by Patrick Stoss. Did a great job, to where I just had to copy the code and change a few things to make it work for our Indicio networks, as you can see here. So you can go to your link, like I just clicked on it, and browse around in here if you want to. I'll talk just a little bit about this and give you an intro to what all this means here. Essentially, this displays 3 of the subledgers that are on the network, right? So the Indicio testnet and other Hyperledger Indy networks have multiple subledgers on them that constitute what we call the ledger. So there's a little bit more terminology for you there. Essentially, the domain ledger, subledger, is the main part where you get to add in DIDs, That's what NIM means, is a did. And then schemas to help build your credential definitions, which is this one, the credential definition. So people are out here testing on this thing, 46,800 writes to our domain subledger on the testnet. It's getting a lot of use. So writing things out here is what an issuer does. Scott talked about issuers. To be able to issue credentials, you have to have these things on the ledger. Anyway, then this pool ledger has the nodes of the ledger in it, and then the config ledger subledger has the rules about how to run the ledger, following the network governance. And there's other things out here. We'll let you go and click on them and see. It shows more details about all this stuff, but it's just going to give you a high-level introduction. And later on, when you add your an endorser to the network as part of our hands-on stuff, then you can come look out here and see your endorser right here on the Indicio testnet when we get to that point. So that's part of why I show that one. Before we get too much further, I just mentioned the word endorser. I should talk a little bit more about roles. Scott talked about roles outside of the ledger, the issuer, holder, verifier. For the network itself, the names of the roles on the network itself are the following. Some of them are these ones here. The trustee is the one who writes those administrative transactions to the ledger. So for the pool subledger and the config subledger, a lot of the administrative transactions will go into there. Yeah, the trustee writes and governs the network through administrative transactions to help make things work. And then endorser, like I said, that's actually the only role on our ledger that's able to write the credential transactions. A trustee can't even write the schemas and the credential definitions and stuff that are needed to issue credentials. I'll get more details about what all that means and why all that is, but this role here is the one that can do that. And he either writes them himself, making him the issuer, or an author can build transactions and then get them endorsed by the endorser. So an author can also be an issuer, or eventually could be an issuer, but they have to have their transactions endorsed by an endorser. And the reason for that is because on a main network, we don't, most people don't run main networks for free. That's the way they charge people to use the network, is to have these endorsed transactions. And so a company might be an endorser where they have clients that are authors where they endorse their transactions for them. Hopefully that gets you at least a start. There's a lot more information available online, and you can ask questions in the chat and we'll get you more information if you need it for that stuff. But the other high level thing we need to talk about is the transaction author agreement here. That is something that, whether you're an endorser or an author, you have to sign this if you are going to write transactions to the ledger. It means you agree that you're not going to write anything illegal, or you're not going to write any PII or anything else that's against the governance. And it's kind of a long thing to read, but if you read through, you can see that it makes sense. It's not super restrictive, but we don't want anybody's pictures out there. We don't want any personal identifiable information on the ledger. So and that gets us to the next tool that I want to talk about, and that is the SelfServe tool. We're almost to the Indy CLI. So if you haven't got your Indy CLI ready to go yet, your screen where you can start typing things in, now's the time to do it. But we're going to tell you a little bit about SelfServe here first. I'm going to pop that guy up here. This is the SelfServe web page for Indicio. Sovereign has one as well. Looks similar. Essentially, you type in the network that you want to use, and today we'll be using the testnet. And then copy in the DID and the ver key that you get through a method we'll show you in a little bit, and then click submit. And that's all there is to it. And this help me get a DID down here can help you to get a DID on, it's got 3 operating systems, Linux, Windows, and Mac. So you can get in and follow the instructions to get an Indy CLI set up for being able to get a DID in in that way. There's multiple ways to get DIDs, and we'll show you that way today, and then we'll also show you how to do it through the Aries Toolbox. Okay, we're ready. Are you guys ready? Here we go. Indy CLI. We're going to open up our handout, I think we called it, and our command line here, and we're going to have you guys follow along as we set up the Indy CLI to be able to do things in it. The Indy CLI is kind of more of an administrative tool. It's very manual and hands-on, but it helps to show you the basics of how a network works, and working in that will give you some of the background and underlying things to help you know what's going on. So what else was I going to say about this? Oh yeah, so it's a place where you can have your own wallets and your own other, and then start managing your own DIDs and your own wallets and that kind of thing. So we'll just jump right in. So here's what I'm going to do. I'm going to copy and paste this thing into over here. Oh, looks like I got that part already set up. You notice I have an extra G on mine. You guys shouldn't put the extra G on. I'm running this from my own environment so you guys can see what it will look like from somebody who's already done this before and has a whole bunch of things already in place, right? So I already have a whole bunch of, let's see, someone has asked me to increase the font size because this is really small. Let me see if I can help with that. Apologies, I won't be able to increase my font size because I was unprepared for being able to do that. So let me start over again here. We'll paste that command in here and hopefully I'm in the right directory. Okay, so this is what you should see on your screen is for session is used as transaction author agreement. Again, if you're not able to follow along or if you have troubles here, you can ask in the chat on Aries, sorry, at the Hyperledger chat channel and the Aries channel. And feel free just to follow along and watch what I'm doing and try it again later. All this stuff is not restricted to just during the session today. So we have I already have a test net, so I'm going to need to create a test net with an extra T on it, but the rest of you shouldn't have any pools on your system. So actually this pool isn't creating a new network pool. This is, as pool kind of means a pool of nodes that make up a network, but this is a pool handle that points to an existing pool. So we're making a pool handle on our system, and now we have the testnet pool handle there, and we'll just go ahead and connect to the Indicio testnet. One more quick comment. Oops. I forgot to add the extra T on the end of that one. I have another thing here, so I'm going to try that again and get to the right testnet. On the previous command, where it says gen txn file equals pool transactions testnet genesis, that if that file doesn't exist in the directory where you ran Indy from, you'll need to put in a full path for that. So there's just a little hint for you. Okay, so once you say you're going to connect to the Indicio testnet, which in my case is called testnet T, you can call it whatever you want, of course. And then you have to read the transaction author agreement. We talked a little bit about that author agreement. And first of all, you have to say you're going to read it. And then, as mentioned earlier, this just talks about what you can and can't write to the network. And we'll accept that agreement and agree to not do anything illegal or immoral or any PII or whatever on the network. So, and now we're connected to a pool, and that pool is linking us to the Indicio testnet. So we're going to keep going here. Copy the next command in here. The next thing to do is create a wallet. and this wallet will hold our DIDs, or as the network calls them, NIMs. And the first thing we'll do is type in this password. Doesn't have to be a really long one, because if someone has to break into your workstation or your system, wherever this is, before they can break into your wallet. So, but it does need to have a password in case someone does break into your wallet. And then the next, or break into your system. The next thing we're going to do is we're going to open that wallet. So we're using pretty much the same command. Put in that same password that we just did. If you mess up your password or can't get in, and feel free to make another wallet of a different name to continue on with our example today. A wallet contains DIDs and NIMs, but it also contains the private parts of your keys and your other, you're needed to who you say you are. Ledger or on the network. Only the public parts are stored on the network. All the private things that are needed to say you in this wallet. So there's a little for you there. Where did we get to? Okay. Then we're going to create a DID. Now, I kind of did a little bit of a disservice here, but I'll explain what I did here. What I did is I didn't make it so this has a seed associated with it. If you add the word seed to the end of this, you need to provide a seed for your wallet, seed or seed equals, and then, sorry, for your DID that we're creating, this new DID or NIM that we're creating. And what that does is that makes it so you can use this DID or seed again at a later time or in a different wallet. And then you store that seed in a special place, and only you has access to it. And then if you lose your wallet, or if you need to put that same DID or seed on a different machine in a different wallet, you can do that, and it'll have the same keys. And there's a lot of good reasons for doing it that way. But for our example today, we're just going to make one with an unknown seed. That's what this does, and create one as an example. So when you do it for real, that's what I'm saying. Learn a little bit more about seeds and creating one, and that's important for the real thing. When you really become an issuer, you'll want to keep track of that seed. And that's a super secret thing that you want to place. In the first letter of it and hit tab. And that's why you came to this training, so you know that you didn't have to type that thing in by hand or cut and paste it, that you could just hit tab complete and it would work. So now you have an active DID, and you have a wallet. And if you look at the command line now that you have, you'll see that your DID is there and your wallet is there, and your pool has been adding on as we went along here. So that sets us up for being ready to do things on the network. So far, everything we've done has been local though. We set up a pool handle locally and connected to the network, right? So there's a connection that's there now. But then the wallet and the DID, all that stuff is just sitting here local. Nothing is on the network yet. So just to keep you in the loop there. So we're just going to type help by itself now and show you what that does. And that shows us that there are essentially the thing I want to point out here is that there are 5 major command groups. We can ignore the payment address one here. That's not that's a capability of the network that's not been put into place. It's not something that we have set up or using right now. It's essentially the ability to make on-ledger payments. So we won't go over that one. But we have talked a little bit about what those are all about already from our examples. But we haven't done much with Ledger. Ledger is the link to comes in this Ledger command here. So here, but probably won't go through them all. We're running out of time for my portion here, but I'm just going to show you that you get a list of all the pools. When you do a pool list on yours, you'll just see the one pool that you've created. So you see all of my wallets there, and then I created a new wallet, so it should be only one did in my wallet, just like there's only one wallet. And again, when we here what that did is, so when you're creating a did and you want to keep track of a whole bunch of them, it's helpful to add the metadata on when you're creating it so that you can keep track of which one's which. It's just a little hint as to what it was doing there. Anyway, so let's jump into the ledger command a little bit. If you hit ledger and then you don't type in tab, you just type the tab key twice. It does a tab complete and shows you all the different commands that that come after the ledger. This are all the subcommands, and if you type in ledger help, it shows a whole bunch of stuff. It's kind of hard to read. It's too much stuff maybe. And so let's just get help for a single command, right? Let's pick the nim command, like we did in the example there. Ledger nim help. We can copy that command in now, and it shows help for the ledger nim command and all the different things you can to add a did to the ledger or manage that did that's on the ledger. And so once you've added your nim to the ledger, you can do a ledger get nim, like the next command here. And so did equals, and I don't think this one tab complete, so I got a copy of mine earlier and paste that in there. So ledger get nim. What do you guys think this command will do? Will it show us our nim on the ledger? No, because we haven't added it to it. So since we haven't added our nim to the ledger, or haven't had an endorser add our nim to the ledger for us yet, our nim with no. So we'll just do a real quick example. We'll copy, oops, the show you that you can, what the output looks like when you have a did that's actually on there. And what this is this is my my trustee. So I'm a trustee on the testnet, and because I manage it and help to manage it, and and that's my public did for myself as a trustee on the Indicio testnet. So I think we're ready for our break. During the break, I'm happy to answer some questions and stuff, but let's cut now to our 5-minute break. And if everyone can come back, it looks like we can just go at the top of the hour, give you a little extra time and go to the top of the hour for our break. And feel free to keep asking questions, and we'll stay online during the break, and we'll see if we can help you out with any questions. Thanks, everybody.
Okay, we're now at the top of the hour, so we'll go ahead and kick into the next section here. So let's see. So I'll first start off by thanking everybody that's presented so far. The intro to decentralized identity, as well as the Indy network tools, is all building up to what we'll be doing in this section, which is our introduction to Hyperledger Aries and some of the tools and code bases that we tend to work with here. So my name is Daniel Bloom. I guess I should go to my intro slide. I am a software engineer at Indicio. I like to think of myself, at least, as a veteran of the community. I've been here for a while, started at the Sovereign Foundation, and then later joined at Indicio. And I have been working in this space since before Hyperledger Aries was even around, back in the day when it was the Indy Agent working group underneath the Hyperledger Indy project. Today, I am a committer on the Aries Cloud Agent Python codebase. I get to put in my 2 cents on pull requests and features as they get added. And I am an active contributor there as well as within the Api plugin ecosystem. Joining me today for presenting these slides is also Shar, so I'll turn it over to her to introduce herself as well.
Thank you, Daniel. As Daniel said, my name is Shar Howland, and I'm a software engineer at Indicio Tech. I'm an active developer on the Aries Cloud Agent Python ecosystem, working on developing plugins and other purpose-built agents and protocols. And I'm very excited to be here today and talk about Hyperledger Aries. So I will hand it back to you, Daniel.
Cool. So today, as we go through this introduction to Hyperledger Aries, we will be focusing on these areas. So we'll start off with a general, what are agents? Then describe in a little bit more detail some of the tools we'll be using, specifically Aries Cloud Agent Python and the Aries Toolbox today. And then give you some of the conceptual background while discussing protocols and messaging that kind of lay the foundation for understanding what's going on in our hands-on portion, during which we'll start up some agents, form connections, issue credentials, and verify those credentials. We have a handout accompanying these slides. This is maybe the 5th time we've brought it up, so hopefully you've got it up by now, but you can scan that QR code or enter that address. I've also put it into the Zoom chat here. I will do so again just to be certain everybody gets access to it. On that handout slide, you will find helpful resources down at the bottom, but also the commands that we'll be running once we get to the point of starting up those agents. So first, with the conceptual stuff. So first, what is an identity agent? To give an informal definition, my informal definition, an identity agent is the piece of software that we use as humans to interact in the self-sovereign identity or decentralized identity world, especially where the native language of a decentralized identity is cryptography, more or less. It's really difficult for us as humans to do all the math involved, so we rely on software, on these agents to help us do that. To give a more formal definition, identity agents act on behalf of a single identity owner. As Scott discussed previously, this could be an individual, could also be a business, university, government, as well as Internet of Things devices. Anything that it makes sense to attribute an identity to can be represented through an identity agent. These agents also hold and use the cryptographic keys to securely perform their responsibilities, of course, as we just discussed. And these agents interact with other agents through DID communication protocols, which we will talk about at length in just a moment. So agents are often split up into a few different categories, or at least they're used to help us talk about different types of agents. A common one that you'll hear thrown around, I think, is cloud agent. And as opposed to having any strong implications about the trust of that agent or whether it's using a particular transport or the ownership of that agent, cloud agent really is a description of the location of the agent more than anything else. It is an agent in the cloud. On the flip side of that, we have edge agents, which are agents located at the edge with the similar, same stipulation that that doesn't necessarily mean that we should or should not trust it or anything of that nature. There are, of course, other types of agents. Ones you might hear are mobile, workstation, server, embedded, browser, blockchain. Anywhere where it makes sense for an agent and an identity to be represented, there's likely a specific enough category that we can use to describe it. So in addition to these descriptions of location, we also have varying degrees of complexity within the agent ecosystem. So starting from the most basic, a static agent. This is an agent that has only a single pre-configured endpoint and set of keys for a single connection. And it does not have the ability to update that connection. This would be useful, especially in my opinion, at least in bridging between legacy systems where REST is the predominant force into a agent and DIDCOM speaking system, using this static agent as the thing that gets triggered on a webhook or a cron job or a RESTful API call. Layering complexity from there, a thin agent might be described as an agent that is able to have a single updatable connection. This might be formed on demand in the cloud. You might think, Amazon Lambdas, for instance. However, similar to a static agent, which is typically very purpose-driven, very use case-driven, the thin agent retains this narrow focus on its job. It has its one job and it does it well. And then going further from there, we have thick agents. And this is an agent that might have multiple updatable connections while still having a very specific purpose. The one that comes to mind most frequently for me when I talk about thick agents is a mediator agent. For those who are unfamiliar, a mediator agent is an agent designed to just hold on to messages for agents that are currently unavailable to receive them in real time. You might think of it almost as a email inbox. So a mediator agent can service many agents, but its one purpose is to mediate those messages as opposed to, go on to do further interaction beyond mediation. So it would be described as a thick agent. And then finally, the most complex, you might term as a rich agent or a feature-rich agent. These are usually the agents that we as individuals will be using to represent ourselves in our day-to-day interactions, where we're exchanging credentials, forming new connections with people we meet at conferences, whatever use case that we have for agents. Even within the rich agent category, I would say that there is still a spectrum, more or less, of functionality where some agents might support one credentialing system and or some agents might not support credentialing systems at all and are purpose-built for, connections and interaction over messages as opposed to just credentials. So ultimately, these categories and this gradient of complexity that I've just discussed is kind of a loosely defined thing. There's no hard and fast rule for exactly what an agent is. And that is because these categories are just here to help us succinctly describe our interoperability goals. So a cloud agent might be capable of more than what we might typically think of a cloud agent as being. That doesn't disqualify it as being a cloud agent, just helps us to understand generally this is what we intended for. Which brings us to the agents that we'll be working with today. To describe these a little bit more, we've got the Aries Cloud Agent Python, or ACAPI for short, as you'll probably hear me say the rest of this presentation. Aries Cloud Agent Python is just a little bit of a mouthful. And ACAPI is a foundation for building decentralized identity applications and services running in non-mobile environments. The Aries Toolbox, on the other hand, is a tool for interacting with Aries agents, and we'll explore a little bit more of its capabilities in just a moment. But to summarize, these are both open source building blocks that you can use for your own custom software solution to issue, hold, and verify credentials, as well as anything else you might dream up to use within a DIDCOM space. So ACAPI is a server, or is rather server-oriented. So I saw a question in the chat about whether ACAPI could be used in mobile environments. You might be able to kludge it and make it work somehow, but it's not really intended for that. So you'll experience some difficulties there, I imagine, especially when it comes to receiving messages, where in a mobile environment, we typically need to actively pull from outside of the system due to the intermittent connectivity of mobile devices. Same story for browsers. You might be able to, push that square peg in the round hole if you push hard enough, but it's just not really designed for that. The benefit of that, though, is that Api is well suited for a horizontal scaling environment such as Kubernetes or OpenShift. Api, excuse me, can act as an issuer, verifier, and holder of anon creds, which is what we'll be demonstrating today. But it also supports W3C credentials in JSON LD format using ED 25519 or BBS signatures. We will not be exploring that in detail today, but I have linked in the handout more reading if you'd like to read in more depth about where support is there and what is possible with W3C credentials versus anon-creds credentials. I will call out that support for W3C credentials is recent. I won't say it's in development still because it is fully functional and available today, but support is ongoing, and as time goes on, I think we'll see a better integration of those systems. Api is also capable of revoking anon-creds credentials. This is a whole other can of worms. It's quite a in-depth topic that you can explore. And again, I've left some links in the handout for that if you'd like to dig in a little bit more. We will not be covering revocation today. And then finally, I wanted to call out that Api supports something we've come to describe as multi-tenancy, or the ability to have a single software package host multiple agents at once in a more efficient than spinning up many pods in a Kubernetes cluster or anything like that. This makes Api a pretty good candidate for agent as a service type systems. That, as well as the horizontal scalability that we previously discussed. So Api is, again, using the categories that we described earlier, is a cloud agent and is a rich agent. It is feature rich. It is capable of many things. The Aries Toolbox, on the other hand, is what we might describe as being a little bit closer to the other end of the spectrum. It is itself an agent, but it's a little special, and I'll describe how in just a moment. So the Toolbox is a development and testing tool first and foremost. It's not really intended as an end user product. And the reason for that being not that we don't intend to put as much polish on the Toolbox as is possible, but rather we intentionally expose some of the guts of the interactions that are taking place as a way of exploring the interactions, and makes it a really good tool for things like trainings, debugging and testing your agents, and just all around useful, hence the name Toolbox here. It's built as a JavaScript application, runs in an Electron window on Vue.js and Element UI as the components that are in use. The Aries Toolbox is a minimal, or again, using that gradient of complexity term, thick agent. It has protocol implementations that are encapsulated into their own components, meaning it's pretty easily extensible if you ever wanted to add your own features to the Toolbox. It also makes use of a feature detection protocol to determine what the connected agent is able to do, and then adjust the UI to match those detected features. The Toolbox as an agent does speak DID communication protocols. These are special protocols used for doing debugging and testing and puppet stringing of the connected agent. So using the Toolbox today, it'll essentially act as a front-end UI for the Api backend. So I wanted to briefly describe at a high level a way of thinking of agent architecture. This isn't the way, this isn't even necessarily the way that Api or the Toolbox handles things if you were to dig in and look at the actual software components. But at a conceptual level, this is a way to break up the different responsibilities and processes of processing a given message. So all agents will have some form of a transport. This is what we're receiving the raw bytes on. Most frequently, we'll see that the most popular transports tend to be HTTP, which is not to the exclusion of HTTPS. In fact, I think usually we're using HTTPS. And in the agent architecture, this receives the raw bytes and then passes it on to the next components here. I've used the term middleware to describe this section of the stack, but I'm not sure I would really endorse the usage of that continued phrase. I use it instead to draw some analogies between agent architecture and the architecture of an average web server. We receive a request, we get the bytes, we have middleware that adds data to the request, and then it gets passed along to the handler for processing. So agents work in a very similar fashion. We receive a message on transport, it goes to the security middleware, where it is decrypted, and the security context is annotated onto the message. So once it arrives at the handler, we know which cryptographic keys originated the message. It's also passed to a state management middleware, where the current state of an interaction is added to the request context, and then again passed on to the handler so that the handler can take the next logical step in the interaction according to the state. To answer a question I see in chat here real fast, the question is, Toolbox means that it is a controller for Api. That actually segues pretty well into this portion of my slides here. So Api has all these pieces from our high-level agent architecture discussion contained within it. Api also exposes something that is generally referred to as the Admin Api. And a controller is connected through that Admin API to the agent. And it is the controller's responsibility to handle the business logic. So making decisions about what needs to occur next based on what I, as an individual or as an enterprise, would like to do next. So forming new connections would be an action triggered by the controller within Api. Issuing a credential to one of your connections is likewise an action that would be triggered by the controller. This Admin API is an HTTP API. So if you absolutely hate Python and want nothing to do with it, that's fine. You can write your controller in whatever language as long as it supports HTTP requests. Data is also sent asynchronously from the agent to the controller via webhooks. So when we asynchronously receive a new credential or receive a new connection request, that data is bubbled up to the controller, and the controller decides whether to proceed with the interaction or not. So to get back to the question that was asked, whether the toolbox is a controller for Api, the short answer is a nuanced yes. It is fulfilling the role of a controller in the sense that it is instructing the agent to perform a certain action. The nuance comes in that the toolbox is actually using a plugin, which I'll discuss in a moment, to do that interaction as opposed to the built-in HTTP API. So in addition to the controller, which has its own set of responsibilities, as discussed, the agent itself then is responsible for the secret storage and management. So making sure our private keys are kept private and that the private portions of our credentials are likewise kept private. It's also responsible for stepping through the protocols defined by DIDCOM, such as connecting to other agents and issuing credentials. And it is also tasked with interacting with the distributed ledgers. And we'll explore that in a little bit more detail as we go along here. So plugins. I saw a question come up in the chat about this one, so hopefully this answers that one. So Api has an increasingly mature plugin system. So it's one of the aspects of my contributions to Api that I'm actually most proud of. I've been really pushing for this plugin system. This allows us to do things like additional protocol implementations, making sure that in order to add such and such protocol, we don't necessarily need to push that all upstream to the main Api repo. You can also add new Admin Api Endpoints. If you would like to automate a workflow that you do frequently, you could use a plugin to add a new endpoint that performs that for you. You can also add custom event handlers. So instead of making it the controller's responsibility to handle these asynchronous events, you can put it into a plugin, have that occur within the agent itself to perform that whatever action is desired as a result of that event being fired. There's also the ability to add DID resolvers, where a DID resolver is the piece of software that pulls the DID document from a DID based off of the algorithm defined by a particular DID method. And we've got a number of resolver plugins in the wild today for interacting with the universal resolver instance, for example. There's one built in for DID Indy, in addition to the native support that Api has for interacting with Indy DIDs. There's also an example GitHub DID resolver out there. And there are links to those in the handout if you'd like to explore them a little bit more. You can also plug in message queuing systems, taking advantage of the events within Api to, for example, if you want to notify your agent as a service client about a new connection that was formed on their agent, a plugin can help you do that. So the plugin that we're using today, and this is actually the repo that you've cloned in preparation for this workshop, is the Aries Toolbox plugin. This is an indirect protocol implementation. This is the DIDCOM admin API for instructing Api to take certain actions. And this is what we'll be using ultimately to use the toolbox with Api. So if I bring up a diagram of what's going on here, we have the toolbox. This is what is actually displayed to us. And then we have Api running with the toolbox plugin alongside it. The toolbox is communicating with Api using the protocols defined by the toolbox plugin. And then we're instructing the main Api agent to interact with another agent, Bob over here, who likewise is communicating back and forth with the Aries toolbox. So just a brief call out here. So we're pleased with where the Aries toolbox stands today, but we're already looking forward to a 2.0 version that will help us to better take advantage of new libraries and frameworks that are available today that were not when we originally started the toolbox. Specifically, we'd like to build on top of an actively maintained agent framework as opposed to the kind of one-off solution we have now for just the toolbox. The prime candidate for that is Aries Framework JavaScript. We intend to use React, which just has a little bit more vibrant of a community in general, as well as within the Aries Hyperledger Aries ecosystem. And is our goal to ultimately have the toolbox resemble a little bit more closely the other agent frameworks underneath the Hyperledger Aries umbrella, and provide us with, in the future, more maintainability and a path forward for DIDCOM v2. So there are a number of other code bases as well that I wanted to call out here. Again, if you absolutely hate Python, you're in luck. There are other language frameworks for Aries available. Aries Framework JavaScript is one that we work with a lot at Indicio, in addition to Api. It is a TypeScript-based framework that is pretty close to feature parity. There might be some differences in both directions with Api. So really good candidate there if you're looking for an alternative to Api that better matches your development workflow. There's also a Aries Framework Go. Again, differences in feature parity, but quite mature as well. And then Aries Framework.net, which is built in C# with, again, a similar set of functionality. Those differences in feature parity kind of leads into the next code base we've got here, the Aries Agent Test Harness. This is a, what do I call it? first thing that comes to mind is an integration test style test harness for other agents, but it's at a little bit higher than integration test level. So using the Aries agent test harness, we can take Api and another instance of Api, and then the test harness will trigger interactions between the two agents, observing the results, and then producing a compatibility matrix between the two agents that were tested. If we're testing Api against Api, that's not very interesting. But when we do combinations of code bases such as Api against AFJ or Api against AFGO, by kind of going through the whole cross product of that matrix of possibilities, we get a compatibility matrix for the entire Hyperledger Aries ecosystem. There is a website that produces reports of that compatibility matrix on a regular interval. I'll have to add that to the handout. I believe that's not currently on there. Let's see. Other Aries agents and services that we have, the static agent Python library. I am particularly fond of this one. I'm the original author and maintainer of the static agent Python library. It holds a little bit of a unique place within the Hyperledger Aries ecosystem in that it is, I think, the only library purpose-built for static agents. So it's especially lightweight, but quite useful. We use it for testing other agents all the time, but we've also used it for proxy mediator service and in other contexts as well. There's also the Aries Mediator service, which is a dedicated repo for deployments of a mediator. This is built using Api, and it provides us with that third party that enables mobile agents to receive messages when they're otherwise offline. And then the last one is a bit of an oddball, the Aries Ascar codebase. Ascar is a secure storage library, which is heavily inspired by the Indy SDK wallet. It is different from the Indy SDK wallet. It has seen a little bit more optimization, I believe, in terms of performance, but it's also a little bit more flexible than the Indy SDK wallet. And we anticipate that we'll see more and more adoption of this code base. It is currently pretty well supported within Api. You have the choice of using the Indy SDK wallet or Aries Ascar. But I think we'll start seeing adoption of it in other frameworks such as AFJ. And then finally, wanted to call your attention to the Aries RFCs repository. The majority of the content that is discussed today is directly available within the Aries RFC repo. Might take you a while to read through all of it, but it's all there. So the Aries RFCs are a great place to go and participate in the development of these protocols if you'd like, or just to see the specification if you're implementing one of these protocols within your own agent. There's a good question in the chat that I'll call out here. So Matthias is saying, wondering if there are any light DIDCOM for IoT environments. So IoT is a really interesting use case that we have a lot of interest in. The DIDCOM v1 standard, which we'll be using and discussing today, has some crypto requirements that make it difficult to implement on IoT devices as of right now. However, in the DIDCOM v2 efforts, which I think I'll let Sam allude to a little bit more thoroughly as he gets into his portion of his slides, is seeking to address that a little bit more. Even before we get DIDCOM v2 support, IoT devices can still interact in a DIDCOM space by delegating to a hub that is DIDCOM capable, for instance, if you've got a really lightweight device. There are some IoT devices out there, I'm sure, that are crypto capable, but that is not universally the case, of course. Okay, so protocols and messaging. So this is a description of what's going to actually be taking place between the agents as we step through our hands-on portion. So we'll start off with what is DID communication. I've used that term, I think, a few times without defining it. So a very simple definition would be where verifiable credentials are about a subject, about a owner of a DID, an identity owner. DID communication is communication with the subject of that DID and verifiable credentials. So DIDCOM is ultimately the way for DID and BC capable entities to communicate securely and privately, which by extension means that it is the way for credentials and presentations to be sent and received between parties. But it doesn't stop there. DIDCOM is also just generally useful as a mutually authenticated secure communication channel between two or more peers, I should say. So you could use it for things like instant messaging, relationship-based user authentication, or in other words, user authentication that isn't strictly reliant on verifiable credentials to make sure that the person I'm talking to is the one that should be allowed to access this particular user on a site. It could also be used for buying and selling, negotiating, whatever. Lots of potential use cases there. VCs, I should call that out, thank you, is verifiable credentials. I should probably call that acronym out before using it again. So DIDCOM has these 5 stated goals, which have a pretty significant impact on the shape and implementation of DIDCOM today. So taking the first 2 together, we have secure and private. This means that we are confident that the person we think we're talking to is actually the person that we're talking to. Or in other words, we're confident our communications are authentic. When our communications are private, we are confident that the information passed from us to the other party is completely opaque to a man in the middle who might intercept that message. There are, of course, a plethora of options today for secure communication, but where DIDCOM differs from these other solutions is these other secure communication platforms rely on key registries, identity providers, certificate authorities, browser or app vendors, or other centralized services to secure the communication. So DIDCOM differs first because it's decentralized. It is not reliant on a federated service to establish the bootstrapping of the trust and interaction. But it also has the remaining 3 goals of interoperable, transport agnostic, and extensible. So interoperability is kind of one of the big pieces that ties into decentralization a lot, in my opinion. So it is a first-class citizen goal for DIDCOM to be interoperable. That means it doesn't matter whether you're using app from such and such vendor with another app from another vendor. It doesn't matter what operating system you're on. Doesn't matter what decentralized root of trust or blockchain you're using. Doesn't matter what the programming language the agent was written in. Interoperability of DIDCOM means that there is no vendor lock-in, no lock-in based on any of these constraints that we often have to live with today. In addition to that, DIDCOM is transport agnostic, meaning that it shouldn't matter whether you're using HTTP, WebSockets, Bluetooth, or email, or the ongoing joke has always been carrier pigeon for transmitting your DIDCOM messages from one party to the other. DIDCOM is not dependent on those transports to make sure that the message is secured. And then finally, extensible. So this one's a little bit more loosely defined in my head, at least. But DIDCOM is an open standards that you can participate in the evolution of, whether that be adding messages to the standard set of protocols or adding a new protocol altogether. DIDCOM can be extended to accommodate that goal. Yeah, I'll leave it at that. So as a result of those goals, we also have a few other attributes or properties of DIDCOM that are worth calling out. So DID communication is message-oriented with one sender and one or more receivers. On receipt of the message, the recipient can either take action or not take action, depending on the state of the relationship with the sender of the message. and can choose to respond with another message back to that sender. DID communication is also asynchronous, meaning that the participants in an exchange of messages are not required to respond in real time. In fact, they cannot be required to respond in real time. That is a stipulation of the protocol. So you might compare this to email, where you might receive a message and it is not at the protocol level a requirement that the person receiving the message immediately respond to that message. There might be some temporal implications as a result of the contents of a message, but that is delegated to the user in the case of email. In the case of DIDCOM, it is delegated both to DIDCOM protocols to determine whether there should be a temporal aspect associated with the messages being exchanged, or to the user to decide when they want to respond. Also, like email, DID communication is routable, meaning that in order to get from A to B, the message can be routed through C. So this means that DID communication natively supports mixed network-like behavior. So if you're familiar with the onion routing network, or Tor, it bounces messages around between a bunch of different participants in the network to help sever any traceability between the original sender and the final recipient of data sent over the network. So DIDCOM supports similar behavior by default with this routing mechanism. It also means that DIDCOM can transfer between different transport types at different hops in the route. So if I have an agent running in my closet, for instance, and it receives a message over HTTP, and it is instructed to relay that message onto my mobile phone, it can do that over Bluetooth, even though it was originally received over HTTP, without any breakdown in the security or authentication associated with that message. So there are some interactions between these different goals and properties that are worth calling out. First, the security of DIDCOM is not dependent on a given transport. I think that's kind of a logical follow-on to what I just previously discussed, where we can transfer between transport protocols. The security is actually wholly encapsulated within a DIDCOM message. That being said, we can use transports and routing to augment the security and usability of our agent systems. For example, using HTTPS as a transport, many of our current agent implementations benefit from perfect forward secrecy, which is a desirable attribute for cryptography. It's something I'm not really well versed in the details of, but you can look up perfect forward secrecy for more information on that. So they benefit from perfect forward secrecy today, even though that is still a long-term goal of implementing natively within DIDCOM. On the other end of that spectrum, though, we have requiring specific transports can actually damage interoperability. So if you're such and such vendor and you have this really cool transport mechanism that you just devised and came up with, and you require only that transport, you're out of luck when interacting with the rest of the ecosystem, which might be more reliant on or more frequently using other transports, such as HTTP. So instead, we encourage people to take advantage of these technologies and their special ability to make certain interactions more efficient through the use of protocols or internally within your agent infrastructure, as opposed to using that as the main point of entry into your agent, so that interoperability is not impacted. So we've discussed transports at length here. We've alluded a little bit to DIDs and their role in this interaction. I won't go into excruciating detail here. However, I will say that DIDs are instrumental in securing our communications, especially peer DIDs when it comes to DIDCOM. And these DIDs have the keys that we use to encrypt the messages associated with them. Building on top of transport and DIDs, we have DID communication protocols, which again, I've alluded to a number of times. So moving on to a more formal exploration of these protocols, to use a phrase coined by Daniel Hardman, a DIDCOM protocol is a recipe for a stateful interaction. There are many layers underpinning DID communication that have their own protocols associated with them, such as TCP, HTTP, managing DIDs, the communication channel used from a user of the Indy network uses a different set of protocols, as well as a different set of protocols for the actual update process, like the algorithm used. And then cryptography also has its own protocols in the form of, Diffie-Hellman key exchanges and others. So DID communication protocols should not be confused with any of these lower layer protocols. Instead, DIDCOM protocols build on top of these lower layers to define protocols with real-world social value, such as forming a connection, requesting and issuing credentials, proving things, buying and selling, all that fun stuff. So DIDCOM shares some thought space with the world of REST today, which is our primary interface for interacting on the internet. It warrants a little bit deeper comparison. So REST stands for Representational State Transfer. DIDCOM is message-based stateful interactions. REST depends on a client-server model of thinking, where the server is generally considered to be the source of truth, and the client is dependent on the server. In DIDCOM, the participants in an exchange are by default peers with roles that are defined by the protocol. On a protocol by protocol basis, the role of one particular participant might mean that they are to be trusted to be the source of truth for a particular aspect. But at the most basic level, DIDCOM does not inherently have that client-server model involved in it. REST is a one request, one response style system, whereas DIDCOM can exchange many messages in order to complete an interaction back and forth between the two parties, not just one there, one back. REST uses HTTP methods to indicate which action that should be taken. DIDCOM is, of course, not dependent on HTTP, as it is transport agnostic. And the action is determined by the message type included in the DIDCOM message. REST uses paths to, again, indicate action, whereas DIDCOM uses these message types for the indication of what action should be taken. And then REST uses paths routed to handlers. And in a similar fashion, DIDCOM uses message types to route to a specific handler for a message. So to have a well-defined stateful interaction, a protocol needs the following ingredients: the name and version of a protocol, its URI that identifies it, its messages, the roles that the sender and receiver can take in the protocol, and then essentially what is a state machine of how those messages and roles are expected to proceed. And then finally, a protocol also can define the set of constraints that it imposes on the interactions, such as I am requiring that messages received in this protocol must be encrypted end-to-end from an already known sender, so an already established connection. So let's take a look at an example message here from a specific protocol. This is the basic message protocol, the basic message. And this is the general shape of it. So analyzing this message type here, we can pick out the different pieces of the protocol described. So basic message is the name of the protocol. Version was 1.0. Unique URI for this protocol is https://didcom.org, basic message 1.0. There is one message in this protocol, which is just the message, which is perhaps a little confusing. There's a sender and receiver role. There's no real state changes, and the events are just sender receive, with both of those resulting in a start to finish, just very simple interaction. So this basic message protocol is a very simple, or basic, if you will, instant messaging protocol for agents. This is more of a toy protocol as opposed to really intending to be the ultimate in instant messaging between DIDCOM connected peers, but it is a basic protocol that we can look at and explore and implement early on in our agent's development life cycle to ensure communication is flowing. So in this message that we just looked at, we have here at the top a type attribute. So the type of this DIDCOM message is a URI that resolves the documentation for this message. But beyond that, it also helps the receiver of the message identify what to do with the message, so that routing the message type to handler aspect that we discussed previously. In this message type, we've got the https didcom.org. This portion of the type is referred to as the document URI, and it also serves as an identifier of the body that created or standardized the protocol. In this case, it is an official didcom.org protocol. Let's see. The first portion of the path following the document URI is the protocol name, which is in this case basic message. And then the next portion rather is the protocol version. This version is loosely following the semantic versioning specification, if you're familiar with that. I say loosely because we can see here that it is omitting the patch number, which is generally required in semantic versioning. Patch number would be accepted, it's valid. The reason why it is omitted in this case is where patch refers to a fix to a major and minor version that does not impact the external API. Since DIDCOM itself is more or less an external API, the patch number can be omitted without loss of meaning. So finally, the last part of the path here is the message type or name. In this case, again, perhaps slightly confusingly, the name is message. This will differ for other protocols and other messages. And everything that precedes that message name is referred to as the protocol identifier URI. And then taken as a whole, this string is called the message type URI. So the message type dictates what attributes are expected to be present in the message. So as dictated by the basic message protocol, we will expect to see a localization decorator attribute, a sent time attribute, and attribute in the message. I won't go through all the attributes here, but just as a simple example of another type of message that is sent, this is the offer credential message from the issue credential protocol version 1.0. And this, of course, includes the R type string that helps us identify what the heck it is and what attributes to expect. And then we expect to see a comment, a credential preview, this offers attach object. And this is, again, defined by the issue credential protocol. Excuse me. So there are two layers that ultimately combine to form interoperable DIDCOM messaging. The agent message, which is what we've been discussing so far and what is typically meant when we say message, and then the encryption envelope or packed message. An agent message is a message sent between identities to accomplish some shared goal. Again, those basic messages, those offer credential messages, all of those things. And then the packed message is a wrapper around that agent message that enables the message to be securely delivered and sealed while in transport from one agent to another. These message envelopes, encryption envelopes, have a couple of different flavors to them, anonymous or authenticated encryption. We typically only really use the authenticated encryption, so I won't spend a ton of time talking about that. These messages are end-to-end encrypted. So even if a message is sent from Alice to Bob through Carol, Carol is unable to access the contents of the message, can only see the external wrapper. For those who are aware of the JSON Web Encryption specification, this is a derivative of that specification. And there are ongoing efforts to further standardize this encryption envelope to better align with already existing standards. So if we take that example message again and then transform it into a packed message, the pseudocode operation for that might look something like this, where we take the message as our message parameter and we stuff it into this pack method that takes the recipient's verification key and my signature key. And verification key in this context refers to a public key in an ED 25519 public-private key pair, and the signing key is the private portion. There's a little bit more going on in the background here than simply this, of course. This doesn't get into the details of how the key is transformed into an encryption key from what is typically just a signing key. The details of that can be explored in a little bit more detail at the Aries RFC repository. And the result of this pack operation is somewhat similar to this. So I've truncated a few values for brevity and clarity here. But each of these values are worth at least knowing generally what they are, I think. So the protected attribute here is a base64 encoded JSON object containing headers for this pack message. Inside of the headers, you'll see things like the algorithm, that's the portion where you'll see a lot of the standard JSON web encryption pieces. It also includes the recipients and the encrypted content encryption key. The ID is an initial vector that is used in the encryption and decryption of the ciphertext, and the ciphertext is the encrypted basic message that we just used as our example. And then a tag is an HMAC of those protected headers to ensure that these headers have not been tampered with in transport. Okay, so with that, we have reached our second intermission here. When we return, we'll begin our hands-on portion with Shar leading, and then we'll step through forming connections and issuing credentials and all that interesting stuff. We are, again, pretty cleanly set for starting at the top of the hour, so I think that makes sense. So with that, I'll hang around and I'll observe questions in chat. So if you have any other questions that you'd like to follow up on, feel free to hit me up. Otherwise, I'm going to go on mute and enjoy your brief break.
All right, welcome back, everyone. I think we're ready to kick it off again and start moving into the hands-on portion of this workshop. So now that we've gotten the background information on the agents, Aries Aries Cloud Agent Python, the Aries Toolbox, and DidComp, we're now ready to start up the agents, create a connection, and issue and verify a credential. And so in each of these next sections, we're going to walk through a demo with screenshots that indicate each step, where to click, which buttons, and what information to enter in. And then we'll transition to a live demo from Daniel walking through the same steps. So my demo with the screenshots is more of a quick primer for the live demo that you can follow along with Daniel to explore more deeply and demo additional interactions. And so the first thing we'll need to do is start up the toolbox and the agents. And so you may have tried this out in office hours or prior to this workshop, but we'll walk through it briefly here. And again, the prerequisite document outlines the steps for cloning both the Aries Toolbox and the Aries Api Toolbox plugin. And so if you haven't done that yet, you can follow those in the prerequisites document. And so we are going to run through these series of commands to start up the Aries Toolbox, and you can find these on the handout that has been shared so that you only have to copy and paste. And so in one terminal, navigate to the Aries Toolbox directory within the Get HL training directory. Run a Git pull to make sure that you've gotten all recent changes into your local repository. And then run an npm install to install all necessary dependencies, and then an npm run dev, which should start up the toolbox, and it should show up in its own window as shown here on the right. And now that we've started the toolbox, in a second terminal, we'll need to start up the agents. And so we'll navigate to the demo folder within the Aries Api plugin toolbox directory within the Get HL directory. and then run a git pull to make sure, again, that you've gotten any recent changes, a git checkout to make sure that you're on the correct HL workshop branch, and then this Docker compose command to build the agents. And if you get a permissions error, it'd be a great idea to run as administrator with sudo to solve that. And this should take 10 to 20 seconds. And at the bottom, it will print a large QR code and an invitation URL that should look something like this window on the left. And so now we'll walk through some quick screenshots to show what this should look like. So on your Toolbox plugin terminal, you'll want to locate the invitation URL for Alice, as highlighted here. And then you can copy that and paste it into the new agent connection bar on the Toolbox. And so after clicking connect, you will see Alice show up as one of the Toolbox connections. And now we will scroll to find Bob's invitation URL. We will again copy that and paste it into the new agent connection bar. And then after clicking connect, we will see that Bob now is also connected to the Toolbox. And again, just a reminder of what Scott mentioned earlier about the agents. These are Alice and Bob, commonly used names in cryptography discussions, and they're a placeholder for different entities. So it could be a university and a student, a business and a customer, could be people named Alice and Bob who have met at a conference and would like to connect. And so with that, I will hand it off to Daniel for a live demo of these steps.
Okay, thank you, Char. So we will first start off with, and hopefully this will help everybody step along and have a little bit clearer picture of what's going on. I know there's a little bit of an issue with slightly blurred images, but we'll go through all those exact steps here as well. So I am currently within I'll start off with the Toolbox actually, just to follow the same order. So I'm in the folder where I've cloned the Aries Toolbox. This might look a little bit different for you. So we'll start off with cding into that directory. And then we'll do a quick git pull, make sure that we've got the most recent changes. And then an npm install to install dependencies. I've already installed dependencies, but I'll go ahead and hit run to see if this is a realistic timing for any of the rest of you at least. While it's running, I'm going to pull up chat and make sure I'm watching that. I'll try to be attentive to chat as we go through these steps. If there's anything that is really just not making any sense, feel free to send it there. Also, anybody who's seeing chat and would like to holler out anything that's unclear, let me know. Okay, so then we're in the Aries Toolbox repo. That is now done. With install, we'll do an npm run dev now, and we should see a window pop up here in just a moment. For any more technical questions, if you run into difficulties, I'd highly recommend directing those to the Aries Rocket Chat channel on the Hyperledger Rocket Chat, and one of our moderators there can help you out in a little bit more detail than I can here. So cool. So we've got the Aries Toolbox running, ready to connect to our agents, which we will now start up. So I am in the Aries Octopi plugin toolbox. I will now cd into the demo directory. And then the command that we want to run here is docker compose -f, and then specify our docker compose configuration that runs both an Alice and a Bob agent. And we'll do an up -- build for good measure. And to answer the question that just came up, the toolbox that I have open here is indeed the tool that we can use for testing and development of agents. And I'll show you how and why it's useful in just a moment. I got to type in my password here. Okay, so this should bring up a number of services. There are 2 services for agents and 2 services for tunnels that enable external connectivity. If you want to send an invitation to somebody over Rocket Chat, for instance, and have them connect to your agent, that is possible. And then we have our 2 invitations and QR codes spat out on the terminal here. So what we're going to use rather than the QR code is we're going to copy the text just above the QR code for Bob first, since he happened to be the last one in. And I'll paste that into the new agent connection box here and hit connect. We see some stuff happening in the background. This is actually the connection protocol taking place. Interestingly enough, Char will be stepping through that in just a moment. And now I need to scroll back up and grab the Alice agent invitation as well. Copy that and paste in here and connect. So once we're to this point, we can open up each of these agent windows. I'm going to say goodbye to my agent list for now. And we now have an Alice and Bob window here. I'm going to increase our sizing just a little bit and put these kind of side by side. So this is the Aries Toolbox. This is the main view that you'll be interacting with when you're connected to a particular agent. There's a number of different features involved here. I'll start off by clicking into the Discover Features tab or section. I'm never sure what to call these. Section, I'll go with section. And this enumerates all the protocols that are supported by the connected agent. And you'll notice in here a number of credentials that are prefixed with admin in the protocol name. Admin issuer, let's see, where's another one? Admin schemas, admin DIDs. There's some more in here somewhere. And these are the protocols that the toolbox is detecting. And then based on that support is populating the agent-to-agent portion with. So regardless of whether your agent is supporting these admin protocols or not, these 4 basic toolbox to agent tools should be accessible and useful regardless. So we can send a basic message directly to Alice. This won't really result in much other than a notification from the Alice agent that a new message was received. I can observe that in a different category, and I'll explore why that is in a moment. We also have a Compose tab where you can manually construct an agent message. Say you're developing a new protocol, or you'd just like to trigger one very specific message in an interaction and send it to your agent. You can do that here. It also has the 5 most recent sent and received messages on the toolbox side. So we can see what's going on between the toolbox and the connected agent. And then we have a full message history, full accounting of what has occurred between the toolbox and the agent. So to briefly explore what's going on in here. So we see the Discover Features. This is what is triggered by the Discover Features section. And we sent a query and we received a disclose, which listed off all those protocols for us. What's another good one? We had an admin connections list. Oh, that's received. I need a sent. Where's the sent? Here we go. Admin connections get list queries for the list of active connections on the agent, and then the response. It's kind of a little interlaced here, just based on the timing of the messages being received, but we see the list of connections, which is interesting to explore, if nothing else. So if your connected agent does support these different admin protocols, you can step into DIDs, which allows you to manage your DIDs of your agent to some extent. Question just came up. Are these messages fake? They are not fake. These are real messages being exchanged between the toolbox and the connected agent. There's also an invitation section that allows us to create and manage invitations. We have active connections. We can see Alice's view of her connections, which includes the toolbox, which is what we're actually using to access this view of the connections. So we don't want to get too recursive there, I guess. But we can see that the active connection of the toolbox is present here. There's also a form here to create a static connection with a static agent. We won't be using that today. We can use this to send a basic message. I can send one back directly to the toolbox. So what I'm doing now is from the toolbox, telling the Alice agent to send me, the toolbox, a message, which is fun. I think, yep, there it is. Shows up in a slightly different location. This makes a little bit more sense when we're remote controlling and communicating with other connections. And then we have credential issuance, which we'll be getting into a little bit more. I'll talk about this transaction author agreement a little bit more then too. Mediation and routing will be unused for today. My credentials, which lists off the credentials received by this agent, and a set of presentations that have been received. Verification, on the other hand, is requesting credentials from a connected agent. So these are my attempts to prove something, and presentations are the list of presentation requests I've received. So there's another question in the chat here. What are the differences between messages and DIDs? Good question. So DIDs are just an identifier, a decentralized identifier, which when resolved contains the set of keys necessary to securely send a message between two different parties. So a message, a DIDCOM message sent between two agents is dependent on there being knowledge of a DID in the wallet with keys associated with it and endpoints so that we can send that message. So with that, we'll now step into the next portion of the walkthrough, which will be actually a description of connecting the two agents, and we can take it from there. So I'll pass it back to Shar.
Thanks, Daniel. Are you able to see my screen?
Yep.
Okay, perfect. So the next thing we're going to do is create a connection between Alice and Bob. And so they each have their edge agents, likely their mobile devices, and the cloud agents that act on their behalf. And so in this situation, we're going to have Alice initiate the interaction with an invitation. And so this invitation is out of band, which means it's not communicated directly through DIDCOM protocols because the communication channel has not yet been established. And with mobile devices, this is often a QR code, but in this demo, we'll be copying and pasting the invitation URL between agents. And so when Bob receives this invitation, he's receiving from Alice an initial connection key, endpoint info, routing keys, and a label. And so the initial connection key is used exactly once, just for sending the connection request message that is triggered by this invitation. The endpoint info and routing keys are sent to make sure that a message that Bob sends back to Alice can reach her. And the label is who Alice says she is. So this is not a verifiable attribute, but more of a suggestion and a convenient way to identify the information, the invitation. And we can absolutely trust it, and identity verification should happen after the connection is formed. So here's what that invitation message looks like. Here we see that the message type is a connections invitation, and then it includes the label, recipient keys, service endpoint, and routing keys that I mentioned. And so after Bob receives the invitation, if he does want to connect with Alice, he will send a connection request back to Alice's agent. So this will contain the label. Similarly, it's a suggestion of his identity, Bob's DID, which he will use in identifying his communications with Alice in the future. And it also includes Bob's DID doc, which is the document containing relationship keys, routing keys, and service endpoints, all the cryptographic information required to secure future communications and allow Bob to receive messages from Alice. So again, here's what that message looks like. Now it's a connections request, and it includes label, connection, DID, DID doc, which is omitted here because it is quite long. And a quick note on the language here. So Alice initiated the connection, but Bob is sending the connection request. So Alice can send an invitation to connect with Bob and give information on how to reach her, but Bob may not send this request to actually connect with Alice after receiving the invitation. Since they are peers in this interaction, there are no imposed requirements. So now Alice sends the same information back from her perspective, her own DID, her own DID doc in a connection response message. And again, Alice's DID is what she will use in identifying her communications with Bob in the future, and her DID doc, which will allow them to communicate securely and allow Alice to receive messages from Bob. And so here's again what that message looks like. Now the message type is connection response. And there are also additional identifiers to make sure that Bob can correlate the request that he sent out with this response. And the connection data that Alice sent to Bob is signed using the key that Alice used in the original invitation. So Bob knows that this response came from Alice, the same person who originally created the invitation. And so now that the DIDs and DID docs have been exchanged, this connection has been established. And a few quick notes on forming connections using DIDComm. These are peer-to-peer connections that we're forming. And again, they are not necessarily direct. They could use a third party, like a Mediator is probably a good example. And it is actually built into the capabilities of DIDComm to have a message routed through a third party. But whatever third party is arranged to hold these messages cannot see the contents of the messages since they are end-to-end encrypted between Alice and Bob. As Daniel mentioned earlier, the connection is not a transport layer connection like a socket or open HTTP requests, etc. It is a DIDComm connection. And so the agents are connected and the interaction is considered complete when all parties, here just Alice and Bob, have securely exchanged their DIDs, keys, and service endpoints for future communication. And so, let's see. Now we will walk through the steps in the toolbox to connect Alice and Bob. Again, apologies for the blurry images. Daniel will walk through the same flow. So hopefully that should help you follow along. So here we have the Alice agent and the Bob agent. And we're going to have Alice initiate this, this invitation again. And so we'll navigate to the Connections tab on her interface, and this will bring up a form to create a new invitation. So we will put in the alias of Bob. That just helps us organize. This is the invitation that we sent to Bob. And then again, the label is the suggestion to Bob of Alice's identity. Then we can scroll down. We'll just want to make sure that auto accept is on, and then we can create a new invite. When we scroll up again, this invitation to Bob should show up here under invitations. And then we can click into it, and there is a copy URL button that will allow us to grab that URL, the invitation URL. And then on Bob's interface, we will navigate to connections and paste in this invitation URL. Once we click add, we should see Alice show up under Bob's active connections. And then we can also verify on Alice's side that we see that Bob is one of her connections. And so now Alice and Bob are connected, and I will hand it over to Daniel for a live demo of this protocol.
Cool, thank you. Just pulling my chat window back up to make sure I can address any questions that arise. Okay. So as Shar noted, we'll first start off on the Alice agent view here. And I'm going to return to a couple questions that were seen in the chat as well in just a moment. So we will, on the Alice agent, optionally, you can put in an alias if you'd like to help you identify a particular invitation. This alias is a name you can associate with the invitation itself. The label is the value that is presented to the recipient of the invitation. If we leave it blank, it'll default to Alice. So I'm going to go ahead and leave it blank for now. We just want to make sure that this auto accept flag is triggered for now. So we'll create this new invitation. Alice now has it. We can copy the URL. And then we will go to Bob's side window here, then navigate to connections just below invitations and paste into the invitation URL box here, and then click the add button. This will happen pretty fast. We now already see Alice's connection and Bob. If I go back to the connections instead of invitations, connections, Bob shows up for Alice. And so we now have Alice and Bob connected. So there was a little bit of confusion of who's connected to who and why is Toolbox showing up in this active connections thing and why am I able to message directly with the Toolbox? So to hopefully bring a little bit more clarity there, I'm going to bring this diagram back in that I shared earlier to describe where our different components are. So Alice, or the thing that you can view as, let me try to get my wording precise here. So this window for Alice is a window into the state of this Api instance here under Alice. When we interact with the Toolbox to agent features, the interactions taking place are occurring between Aries Toolbox and Api plus the Toolbox plugin here. So that's why we can send a message directly to the Toolbox. The Toolbox itself is actually a connection of Alice. And so when we look into Alice and see her view of the world, we see the Toolbox present there. We just have a limited set of functionalities that we support with the Toolbox. And so we don't do verifiable credentials exchange here. And that's why we've got Bob to interact with. So if I now go to messages and if I select Bob and I send a message, I guess I should do something a little bit more interesting than just jargon. Let's say, hi, Bob, and send that. What has taken place is a command from the Toolbox has been sent to the Toolbox plugin, which triggered Api to send a basic message to the connection specified in the command, which in this case was Bob. And so by sending this command along this transport mechanism from Toolbox to Api, we're telling it to do something between these two parties. So a message was sent. If I view messages on Bob and then select the Alice conversation, I see that message has arrived. So what's occurring on the other side then is Bob, on receipt of a new message, the Toolbox plugin captures that event and sends a new message to the Toolbox, which then updates our window here. So hopefully that's answered the question of where the interactions are taking place. I see another question here. In a production scenario, the Toolbox will be replaced with a mobile app interface to trigger commands in Api. I think this is more reflective of a controller scenario. So if we think back to the controller, which is interacting with Api over the Admin API and HTTP, we typically use that from the enterprise perspective. That is where Api is well suited. For mobile agents, usually we would like to have all the data as close to the user himself as possible, him or herself as possible. So a wallet is stored on the actual mobile device in the base case, and that's where all the secrets and private values are shared. That mobile agent is then capable of contacting directly the Aries Cloud Agent Python, and then on the other end of that exchange, the enterprise user can interact with the Aries Cloud Agent Python with their controller. So Toolbox is analogous to controller as opposed to a mobile app interface. However, that is technically possible as well. That is not certainly out of the question by any means. Okay, so I'll do a little bit more discussion here in the connections tab. So if we expand the Bob list item here, we see a little bit of interesting information, which I know has been partially addressed by Sam already. This is the DID for Alice that Bob uses for that relationship, if that makes sense. This is unique from any other DID that Alice has in her wallet. She only uses it with Bob. This is a peer DID. This DID is never written to a ledger because we like to keep these DIDs private, so the context of that DID remains something that is only present within our wallet. This removes points of correlation that can be used to fingerprint attack people and observe traffic as it flows between parties. So by keeping it pairwise, peer, off ledger, we have better privacy guarantees there. It's also notable that this does not include the did : method : prefix. This is a topic of ongoing work within the Akapai community. Akapai, as a very early entrant into the identity agent game and one of the first Hyperledger Aries agents, has a little bit of a history behind it that I won't get into too much detail, but this is an Indy DID, an Indy NIM, if you will. And in the very near future, these will properly be prefixed in all views of this DID. In this particular case, since it is pairwise, I should clarify, this would actually be a did : peer : and then a did value. Okay, with that, I'm going to pass it back to Shar for our next steps.
Thank you, Daniel. Great. So now that we have connected the agents, we can practice issuing and verifying credentials between them. And so the issuer is the entity who decides which credentials to issue and to whom. You might think of how a university will issue a diploma to a graduating student, or how a business issues a credential to employee, perhaps to give access to facilities, for example. And so in order to issue credentials, the issuer interacts with the holder, who's the person or entity receiving the credential, and they write to the ledger. They put certain public information related to the credential on the ledger, so that when the holder wants to prove to someone, a verifier, that they have this credential, a verifier can read this information from the ledger to make sure that this credential was in fact issued by this specific issuer. I'll also briefly call out that we are using Indy and OnCreds, as Daniel mentioned earlier, for this workshop. So there are specific schema and credential definition requirements specific to a non-creds. Akapai is also capable of W3C credentials. That's not something we're covering in this workshop, but yeah, just to mention that the Indy and OnCreds specification enables zero-knowledge proofs and selective disclosure of credential attributes, so it has better privacy guarantees for verifiable credentials and also allows for replication. And so now we will talk about the issuer in context. This diagram should look a little bit familiar from what Scott talked about earlier. We have the issuer, the holder, and the verifier again. And so we will focus now on the steps that the issuer takes to issue a credential. So the issuer needs to write a DID, schema, and credential definition to the ledger. And after that, they can sign and issue the verifiable credential. And now the holder has the credential. And so we'll break down each of these steps and work through it in a demo. So again, this first step, the pre-issuance steps are to anchor the public DID to the ledger, write a new schema to the ledger, or alternatively, you could retrieve a pre-existing schema from the ledger, and then use that schema to write a credential definition to the ledger, and then finally issue the verifiable credential. So we will start with this first step of anchoring a DID. This is just briefly reminding us of what Lynn talked about earlier with the endorser and author roles. Again, the endorser has privileges to write to the ledger. The author authors the transactions. In this demo, our issuer will have both the endorser and author role. So our issuer will create the transaction and then endorse it and write it to the ledger as well. And then we also need to sign the transaction author agreement, as Lynn mentioned earlier. And so now we will navigate back to the toolbox. And in this interaction, Alice is acting as our issuer. And so we'll navigate to the DIDs page on Alice. And then we will also pull up the Indicio SelfServe website that Lynn showed us how to use earlier, where we can get an Indicio endorser. And we want to use the testnet to, because this is a demo. And then we will copy and paste the DID and the verification key into the SelfServe website, like so. And then after clicking submit, we will just make sure that we've gotten a 200 OK response. And then back on Alice, the issuer, we need to activate the DID. So we can either use this activate DID button, or we can select the DID that we want from the drop-down menu at the top. And once we do that, this DID will show up. This is our registered DID. And so now I will turn it over to Daniel for a live demonstration of these steps.
Okay, thank you. So to start us off here, I'd like to again call your attention back to the handout slide. This will have a couple of links that we're going to be using in this interaction that we'll need to pull up. I'll again drop this into the chat to make sure everybody's got a handle to it. So we'll start off on the Alice side, which is going to play the role of issuer in our exchange that we're about to trigger. So we'll first go to DIDs so we can create a new public DID for Alice. This will trigger the transaction author agreement page coming up. As this says, this module requires signing of the transaction author agreement, as we'll be influencing the writing of transactions to the ledger with this module. This will bring up the text of the transaction author agreement. You can read it if you like having really engaging reading on legal stuff. I'm going to go ahead and hit accept, having previously reviewed this document, and hit submit. And now we are able to interact with this DIDs section here. So I'm going to create a new DID. I'm going to give it a label of public just to help me easily identify that this is the DID that I've written to the ledger. So to clarify though, this is only creating the DID. In order to actually get it on the ledger, we'll be taking the steps that Shar described of going through the SelfServe application. So back to our handout page here. I'm going to click on the Indicio SelfServe link in the other resources used section, which will bring up the SelfServe app. I'll jump back to Alice, expand the public DID I just created so I can see the attributes of the DID, copy the DID value out here, paste into this field here, and then copy the ver key or verification key value and paste here. I'll hit submit, and we get back a status of 200 OK, and a message saying that we've successfully written our NIM identified by this DID to the ledger with role endorser. It's also really important that you use the testnet as opposed to the demo net, because that's what our agents are connected to. So if you've accidentally done demo net and hit submit already, you can do the same process just with the testnet and it should be fine. Okay, so returning to Alice, we now need to make sure that this DID will be used for our future ledger transactions. So we click the activate button, and then the DID in question also appears at the top here. So this is a quick way to switch between other DIDs if you'd like to. But that DID corresponds to the one viewed there. So we are now prepared to write transactions to the ledger as we continue with our credential issuance process. And with that, I'll turn it back to Shar for our next steps.
Great, thanks, Daniel. Okay, so the next issuer step is to write or retrieve a schema. And so a schema is the data organization structure that defines the attributes in a credential. So for example, in an employee credential, the schema would likely have first name, last name, address, date of hire, security clearance, anything that any of the information that the employer wants to verify about the employee. And so this is what the JSON of the schema looks like. It has a schema name, version, ID, and shows the attributes here. That's just first name, last name, and age. And after we have written the schema to the ledger, we can also see it on the ledger using the indyscan tool that Lynn demonstrated earlier. And if you are retrieving a pre-existing schema, this is where you'd want to retrieve that schema ID. And so for a quick demo of how to create a schema in the toolbox, we will navigate back to Alice, the issuer. And now we are going to click on this Credential Issuance section. And we will click Create under Schemas. And this will bring up a window to create a new schema. And so you can enter in a name and then a version number. And this has to have either 1 or 2 decimal points. So this could be 1.0 or 1.0.0. And then you'll want to add in attributes. Here we're just keeping it really simple with name and age. And these must be all lowercase. And if they include multiple words, they must be connected by an underscore. And so once you click create or confirm, you should be able to see the schema listed here under your schemas. And so now that we have created a schema, we can use this to write a new credential definition to the ledger. And so a credential definition creates the issuer-specific cryptographic keys necessary for issuing a credential. And so while a schema is the collection of attributes in it's the collection of attributes in a credential, it is not associated with any entity. And so the credential definition is what binds a schema to a specific issuer, so that when the holder is then presenting their credential, the verifier can see that yes, this credential was issued by this specific issuer. And so creating the credential definition generates cryptographic keys for each attribute with both a public and a private portion. And the public portion is stored on the ledger with the schema. This is what allows the verifier to verify that the issuer issued the credential. And the private key portion is maintained by the issuer, and the issuer uses these to sign each attribute. And there needs to be this key pair for each attribute, because as we'll see later, a holder might choose not to present all of the attributes in one credential. They could choose to only reveal a subset of the attributes in one or more credentials. So here again, we can see the JSON of this credential definition ID. We see that it has the credential definition ID and then the schema and attributes that it is associated with. So now we will do a quick toolbox walkthrough of creating a credential definition from the same schema that we just created. And so under credential definitions, we will click create. This will bring up a window that allows us to choose from a drop-down menu of our available schemas. And here we just have the one, so we will confirm that. And this should show up under our credential definitions. And this calculation can take a few moments, so it might not show up immediately. But with that, I will hand it over to Daniel for a live walkthrough of these steps before the final credential issuance step.
Okay, thank you, Shar. I'll start again with a brief call out to some more resources within the handout. So we've discussed non-creds and the revocation. Well, we've alluded to revocation rather, and there's been a few questions, relevant questions in the chat regarding revocation. You can find more details on each of those topics within the additional reading in the handout. While we're here, I'll also really quickly bring up the indyscan page that we can actually view the transactions for on the ledger. So if I go to domain, I'm going to do a really quick scan for my DID that I just anchored to the testnet over here. So that's a DZD. Let's see if I can spot it. Yeah, here we are. So DZD, ledger written to the transaction 6 minutes ago. So this is an interesting way to explore the transactions as they arrive on the ledger, as Lynn very aptly pointed out earlier. Now, as we're creating DIDs here with the toolbox and anchoring them with the SelfServe app, we should see them showing up there. Same thing with the schema that we'll create in just a second. So I'm going to do that now. Skipping over to Alice, going to Credential Issuance, which is about in the middle of the list here. So I will create a schema. What am I gonna do? I'll start off with something really simple just to get something quickly down, and then we can come back for some more realistic credentials in a moment. And we'll say name and age, I guess. We'll include those very basic attributes in this credential. In reality, age would probably be date of birth as opposed to the number age, because it would not be relevant for forever. So I'll go ahead and create that schema though. And then just for the fun of it, I'll see filtering by schema on indyscan. I can hopefully spot my transaction. Hold on, I've gone too far back. I don't see my transaction. Maybe I need to refresh. No, it automatically refreshes. Oh, I'm not sure why I'm not seeing my schema. Maybe I need to come back to that.
So the refresh on indyscan takes a little bit.
Okay, gotcha.
Here, but that just does take a minute sometimes to do the refresh, and pop up at the top of the list is where it should show up right after you've made it.
Cool, good to know. Thank you, Lynn. I'm just being too impatient, I guess. Cool. So we'll go on to our next step here then, which is creating a credential definition from our schema. If you want to inspect the schema, you can see that it's got our name and age attributes. You can see the schema ID. This is the ID value used to identify this schema, both on the ledger and within Api and the credentials. And there's a little bit more in-depth detail that you can expand in that JSON body as well. So to create a credential definition, this is very simple. We just select the schema and say confirm. So as Shar pointed out, this does take just a moment. The reason for that being that it's generating RSA keys in the background for each of those attributes, so it can later use that in the credential issuance process. For those who are unfamiliar with RSA keys, they're a relatively computationally intensive key to generate. So it takes just a moment there. But now we have our credential definition. Sometimes if this is being a little slower than usual, you might want to hit that refresh button just to see if we happen to time out before we actually receive the data back. So refresh would help with that. So we now see our credential definition. The cred def ID here looks very similar to the schema because we are both the issuer of, or issuer is the wrong word, author of the schema as well as the cred def ID. So it is prefixed with the same value, which is our DID. I should call that out a little bit more explicitly. And then there's some version information, the name of the schema, and the schema version. In this case, we have an indication that it is using CL signatures. I believe that's transaction number, and then the name of the schema, or a joint name from the name and version put together. Let's see. So with that, we are now prepared to issue a credential to Bob. But before we get into that process, I'll hand it back to Shar with the discussion of the next steps.
Thanks, Danielle. Great. So back to the same diagram, just to make sure we're oriented in the steps. We have written the DID, schema, and credential definition to the ledger, and now we're ready to sign and issue a verifiable credential. And so this returns to those issuer responsibilities that we talked about a bit earlier of deciding who is issued which credentials. So we'll need to select the connection to be the holder who will receive this credential. We'll select the credential definition to use to create the credential. And then we will enter in the values for the attributes of the credential. This interaction can be initiated either by the issuer or the holder, which will show in the message flow that allows the credential to be issued. And so, like I said, the holder could start this interaction by proposing a credential. They would send that to the issuer, which would trigger an offer credential message sent to the holder. Or if the issuer is starting this interaction, they would just offer the credential, and then the flow is the same no matter which party initiates the interaction. So once the holder receives that, they can request credential, and then once the issuer receives that, they will issue the credential to the holder. And once the holder receives the credential, they will send an acknowledgement back to the issuer, and then their side of the interaction is complete. And when the issuer receives that acknowledgement as well, their side of the interaction is complete too. And so a quick note that this language is a bit awkward and not how people would naturally talk about this interaction. But this is the language that is used in the messages that are sent back and forth to enable this credential issuance. So we're just using it to show the developer language around this message flow. And so back to the toolbox, we'll quickly look at how to actually issue a credential. We are still on this credential issuance tab on Alice the issuer. And so now we can click create under issued credentials. And so this brings up a window that allows us to issue a credential. We want to choose the connection. Here we'll choose Bob, and the credential definition on which to base this credential. And then we can optionally add in a comment. And after selecting the credential definition, this brings up the attributes associated with that credential. So maybe Bob's full name is Robert, and that's what should be on the credential. And so we can just fill in those values and then confirm. And now this issued credential should show up here for Alice. For Bob, the holder, we will look for this credential under My Credentials, where the holder holds their credentials, and we see that this credential has appeared. And so to reiterate, a verifiable credential is a signed statement with attributes about a subject, and it contains metadata about the credential, attributes about the subject, and the proof, the signature from the issuer. And so with that, I will hand it over to Daniel for a live credential issuance.
Thank you. Okay, let's see. So starting from Alice, our issuer again, we will remain on the Credential Issuance tab, and we will click the Issue button. This will prompt us to select a connection. We've only got two in our agent right now, Toolbox or Bob. We want to send it to Bob. The Toolbox won't know what to do with these messages. And then we'll do a credential definition. And this is our credential definition for the test credential that we just used previously to create. I said that a little backwards. That is the credential definition we just created a moment ago. We can optionally add a comment. And then we're going to add some values for our attributes that we're issuing in this credential. So in the real world, this would obviously look a little bit different. If we actually wanted to emit binding credentials, we'd go through some process to actually verify the identity of the person on the other end of the connection. Whether we use analog credentials for bootstrapping into that system or not, or some other mechanism. Usually we won't just say, yeah, here's some attributes that I came up with in this process. But I'll go ahead and hit confirm, and this will trigger the credential to be sent from Alice to Bob. We now see that it has showed up in the issued credentials side on Alice. If we go to My Credentials on Bob, which is just a little bit up from the bottom here, we see the credential issued here as well. So it is credential act state, meaning that the credential exchange has completed. Oh, my screen just said participants can now see my screen. So hopefully you've been seeing all of what I just did. Shout out in the chat if you have not, and I can repeat a few steps. So now that the credential is issued, what actually took place here was first the message to instructing Alice. I should bring up my diagram again in just a moment. So first, the toolbox sent the command to issue the credential. That was received by the Aries Api agent, who then issued the credential to Bob, who then notified the toolbox that a new credential offer had been received. The Api instance we're using has been configured to automatically accept those credential offers. In normal circumstances, that would normally be something we'd allow the user to decide whether they're going to accept the credential or not. And then a credentials exchange took place between the two parties. And this was the exchange that Shar described, where credential offer was sent, credential request was sent back from Bob, and then issue credential message sent from Alice to Bob, and then credential acknowledgement sent back to Alice. The issue credential protocol is pretty well defined. You can find it in the Aries RFC repository, but I think it's worth briefly calling out that in Indy non-creds workflows, we start from either proposed credential or offer credential. And that is because there needs to be some exchange of blinded secrets between Alice and Bob in that process. Other credentialing systems might have fewer requirements on the number of messages exchanged back and forth, such as JSON LD-based credentials. However, that does come with the downside of in JSON LD credentials, you lack private holder binding, which is the ability to say that this credential and this credential, while distinct objects, can be strongly correlated back to a single holder for both credentials if they were issued to the same individual. Mateus in the chat brings up a good point that I'll bring up as a brief aside. So all of this communication taking place between Alice, Bob, and the toolbox is taking place over an HTTP connection. Technically between the toolbox and Alice, it's actually a WebSocket connection, but it is taking place over HTTPS or WebSockets with SSL. And same between Alice and Bob. So while DIDCOM provides the security necessary to ensure that Alice and Bob are the only ones able to view those messages, we still strongly recommend using secure transports, especially when we're talking about the internet here, where anything could happen. And I will not even pretend to say that DIDCOM security has been as thoroughly vetted as HTTPS. So again, taking advantage of the transport to augment the security of our system is wise. Okay. So thank you, Matthias. I might be pronouncing your name incorrectly, I apologize, but that was a good point to call out there. So we now have issued a credential from Alice to Bob. And another thing that comes to mind that bears mentioning is in Indy non-cred systems, there's no indication on any ledger whatsoever that this credential was issued from Alice to Bob. The only records on the ledger are that of the schema and the credential definition. Everything that takes place between Alice and Bob when issuing a credential is a private interaction, which is not publicly auditable in any way, at least via ledger. It is strongly discouraged to ever put personally identifying information on a ledger, as Lynn described earlier when he was talking about the transaction author agreement. It is in fact against the transaction author agreement to include that sort of information on the ledger. Maro brings up another question. The schema and CredDef are synonyms, aren't they? Shar did a really good job of explaining this, so I'll try to reuse the same words that she used. So the schema is a collection of attributes that we anticipate being contained within a credential. It is, however, not bound to any one particular issuer. The credential definition is a separate ledger object, which does exactly that. It performs the binding from attributes to be issued to a specific entity on the ledger. So the two are not technically synonyms. The schema is just attributes, a listing of attributes, and the credential definition contains the DID of the issuer who will be using that credential definition, and the public values of the keys used to issue the credential ultimately. So it's through the cred def as opposed to the schema that we're actually able to perform verification later on using the ledger as the source of truth for those keys. Another question that has come up, how does the requester view the credential issuance if it's not viewable in the ledger? I'm not exactly sure which party you're referring to when you say requester, but I will say, so DIDCOM as a peer-to-peer interaction already establishes that there is a clean and secure communication channel between two parties. So all information is transmitted over that channel. It is then the responsibility of the recipient of the credential to make sure that they correctly store that credential in their wallet for future use. And then if the issuer would like to keep track of some data about the issue of the credentials it's issued just for its own purposes, it is permitted to do so in that issuance process. So there's no external system, no external database to these two parties that has any record of that though, since it takes place between the two. Okay, with that, I think we are ready to proceed on to the next step, which is verifying presentations. So I'll turn it back to Shar.
Great, thanks, Daniel. So now that we have issued a credential, we can now practice verifying it. And so, whereas the issuer had to decide which credentials to issue to whom, the verifier must decide who and what to trust. And so to do that, they will interact with the holder, read from the ledger, perform cryptographic computations to verify that the attributes presented were issued by that specific issuer. One thing the issuer does not do is interact, or one thing the verifier does not do is interact with the issuer. So the verifier is only able to read the information written to the ledger by the issuer when the holder approves the verifier to do so. And so for the sake of simplicity and reducing the number of windows to navigate on a screen, we're having Alice play the role of both the issuer and the verifier in this demo. And roles are not set permanently between parties. The role is unique to the interaction. And so this works just fine. And it is also entirely possible that the issuer is the verifier. For example, if an employer issues an employee credential, they might want to verify that to identify the employee. But we also just want to emphasize that the issuer and the verifier can be different entities who do not interact and cannot gather or exchange information about the holder without the holder's knowledge or consent. But they are able to trust each other, as Scott mentioned at the beginning of this workshop, because they write and read from the ledger. And so we will return again to this diagram where we saw the steps for issuing a credential, but now we'll move to the verifier side. And so first, a presentation must be created. Either the verifier requests presentation or the holder offers presentation. We're going to focus today on the verifier requesting presentation. And then upon receipt of the presentation, the verifier reads the DID, schema, and credential definition from the ledger and verifies the attestations. And so here, again, we will show the flow of messages necessary to verify a credential. And again, this is more of a developer-friendly language than the way that people would normally talk about this interaction. We want to show what the message flow looks like. So optionally, the holder can propose a presentation, which would trigger a presentation request message from the verifier, or if the verifier is initiating, they would start this interaction with the presentation request, and then the message flow is the same regardless of who initiated. And so if the holder wants to approve this request, they can do so and then send a presentation back to the verifier. Then the verifier must verify the presentation, and then they will send an acknowledgement back to the holder. Once they've sent their acknowledgement, their set of interaction is complete, and the holder receives the acknowledgement, and the presentation interaction is complete. And so to verify a credential, we'll have the verifier request a presentation from the holder and indicate which attributes from which credentials should be presented. And so back to the toolbox, where Alice is now acting as the verifier. We will navigate to the verification tab at the bottom left of Alice's interface. And we will choose to request a presentation, which brings up a window where we can choose the connection. We will request a presentation from the holder, Bob. We can add a name to the presentation and optionally add a comment. And now we can add in the attributes that we want to verify, and then we can select the credential definition ID under restrictions if we want to say, we don't want to verify the value of this attribute from just any credential, but only from this specific credential associated with this credential definition ID. That might be if I go to the bank and need to verify my identity to access an account, the bank would likely accept if I presented the name on my passport, but not the Dunkin' Donuts rewards card that Scott mentioned earlier. So for this simple example, we will just verify both of the attributes, name and age, from the specific credential definition that we created earlier. So we can create that verification request, and now we see that this presentation was requested from Bob. So now on Bob's window, we can navigate to presentations, and we see that this presentation shows up under his list of presentations. And in the same way that the issuer issues credentials from this credential issuance tab, and then the holder accesses them and holds them in the My Credentials tab, on the verification side of that, the verifier uses the verifier tab to request verification, and then those show up as presentations for the holder under the presentations tab. And so before a live demo of verifying a credential, we'll just talk about a few different types of presentations. So we have just shown the simplest example of a presentation, which is called a full disclosure presentation, in which all the attributes are revealed from one verifiable credential. Another type of presentation is the multiple credentials presentation, or the composite presentation, in which all the attributes are revealed from two or more credentials, because one single credential doesn't contain all of the required attributes. So this might occur when multiple specific identification documents are required, like a passport and a piece of mail to your address. Let's see, then selective disclosure is when only certain required attributes are revealed from one or more verifiable credentials. So instead of revealing the entire contents of a credential, you have the option to only reveal a subset of those attributes. And then a predicate proof presentation is when we only reveal a true or false value. A common example is age. The verifier does not need to know if you are 22 or 60, if it only matters that you are over 21 years of age. So this is a great way of preserving privacy while verifying necessary information. And then lastly, revocation, which has been mentioned a few times, is the ability to revoke a credential. For example, if a credential expires, or for whatever reason the holder is no longer eligible. So we will not be covering this today, but I'll just briefly mention that revocation is supported by the Indy non-cred standard, and there has been significant work put into supporting it within Api as well. So with that, I will pass it back to Daniel for a live demo of verifying a credential.
Cool, thank you. Okay, so starting off again with our Alice and Bob agents, we've got Alice. To reiterate what Shara just described a moment ago, Alice was our issuer in our original exchange, but we're now going to switch roles, and Alice will become a verifier. Shar already said all of this, but the roles of a particular participant within an Indy and non-cred system is dynamic. Yeah, you can be an issuer, you can be a holder, and you can be a verifier all at the same time. But it is important to note that the fact that Alice issued the credential that we're about to verify is not significant in this exchange. Alice is still using the values written to the ledger to verify the presentation that Bob sends her. However, it's also valid to call out that Alice being both issuer and verifier is also a perfectly valid use case in the context of, for example, if I am an employer and I issue a proof of employment credential to my employees, and then later when they come to the employee cafeteria, if I want to offer them a discount based on proof of employment, they can present their credential proving such, and then give them a discount on their sandwich or whatever. Because I, as an employer, was both the issuer and verifier, that was not instrumental in that exchange. It actually helps decoupling systems within an organization. I don't have to know what software issued that credential. I just need to know how to verify it later using the same decentralized root of trust in the form of the Hyperledger Indy distributed ledger. So with that discussion out of the way, reiterating some of what Shar said already, we'll now go to the verification section on Alice and request a presentation from one of our connections. Let's go with Bob, and we'll put some name to this. I'll just say test for now, since I've got only a very simple dummy credential to work with at the moment. You can optionally add a comment. Now I'll ask Bob to reveal some attributes about himself and name and age. I'm cherry picking these, of course, because I know Bob has those attributes in his wallet as issued by a verifiable credential. So now I'll go ahead and hit confirm. And in just a moment, we see the presentation in its final completed state of verified, with the verification coming back as true. We can also see the attributes that were revealed as a part of that verification process, which in this case was the name of Bob and the age of 42. I think this is pretty obvious, but just in case it isn't, the verified of true is a cryptographic verification. It does not necessarily mean that these values meet some other business logic determined threshold or requirements about these verified attributes. So layering up above Akapi, we would take this verified status of true, and then combined with the revealed attributes, determine whether we want to proceed in whatever other business process that we were in the middle of engaging in with this, our other connection. You can also explore in a little bit more detail what's going on under the covers. So we see the presentation request. Let me pull up this diagram for a refresher of the process that took place between the two, though. So Alice was the verifier over here, Bob was the holder. We began with a presentation request as opposed to Alice beginning with a presentation proposal. So the request was sent to Bob, and Bob, whose agent is currently configured to automatically approve any presentation request, approved it automatically and then sent the presentation. The verifier then verified it and then sent an acknowledgement back to Bob, entering complete state for both of the parties. So in a typical exchange, this would again be something that would either be a decision made based off of a business process, business rules, automation system, or whatever. It might also be defined by a machine readable governance framework, which verifiers who are willing to present what information to might be something that is well defined within your legal jurisdiction. Or it could just be left up to the user directly. This connection would like to see these attributes about you. Are you okay with that? The user would also even have the ability to select which credentials to supply the attributes from if there are multiple credentials in their wallet fulfilling the same attributes. So after deciding that process, deciding which credentials to use in that process, the holder sends the presentation and the verifier checks it. So we should be able to see evidence of each of those steps in this object. So we see our presentation request. We see our requested attributes here, name and age. I said those backwards. There, we could have supplied some restrictions. You can say that it must be from a certain credential definition ID or a certain schema or a certain issuer, which is more or less the same as the credential definition ID, but same difference. We can also see that we did not request any predicates. We see some Api specific things. We see the actual message that was sent as the presentation request here. So this is the format that it takes, not quite over the wire since this would be encrypted, but as delivered from Alice to Bob at least. And it is a present proof 1.0 request presentation with an attached request presentations object. And this is a generic way of stuffing credential system specific data from verifier to holder in order to communicate the credential system relevant pieces. So in the case of Indy non-creds, that was of course, specifically which requested attributes and which predicates. A W3C credential system wouldn't look quite the same there, of course. Then we can also see the presentation that was sent back from Bob. See the raw value of the revealed attribute as well as the encoded value. This was the value that was actually used in the cryptographic verification process. And the age with its encoded value, since it was an integer value already, it remained an integer value. And then there's also opportunities for doing self-attested attributes in Api's support for credentialing and predicates. We also have some unique identifiers here. This is not the complete set of the presentation. There's some incredibly large arrays of numbers that are actually omitted from this data structure. So this is not perfectly representative of what data is sent back between the two, but for perusability, at least, this is the information that's included at this point. So the proofs are the key attribute that are missing from this data structure, which again are pretty large sets of numbers with attributes associated with them to determine how they should be used in the cryptographic verification process. To briefly call out a question that was answered in chat already, which cryptographic solution is being used? So Indy non-creds takes advantage of the, let's see if I can get the name right, Kaminish, I forgot the L already. Sorry, whoever L that was and who came up with that signature scheme. But there are more details in the handout on the specifics of that CL signature suite. If you want to dig into that crypto, if that's your cup of tea. There's also more details on the Indy non-creds specification at large within the handout. There is a push ongoing for the ability to use different signatures within a non-creds. That's pretty early on. It's just a twinkle in somebody's eye at this point, honestly. But we anticipate that BBS plus signatures should be able to support the same level of functionality that CL signatures are supporting. And thanks for the person that put the full definition of CL in there. Okay, I see a question here. How did Bob confirm the presentation request? Yes, I should call that out. So I described the process where Bob would approve which attributes were revealed to the requester. For the sake of simplicity within the toolbox and within this demonstration, that part has been automated out. So it just took place in the background without any intervention on our part. But within the admin protocols used by the toolbox, there is actually a mechanism for determining which credentials we would like to use and sending it on to the plugin. The toolbox itself is just assisting in automating that process. I believe even if we check our message list, I apologize for the background noise. There's a yard work going on right outside my window, so hopefully that's not picking up too clearly on my mic.
It's not too bad. We can't hear it.
Good. I might have clicked away too frequently for it to be visible here. But on receipt of a presentation request, the Toolbox plugin will send a message to the Toolbox saying a presentation request was sent in. It's requesting these attributes. These are the credentials that would fulfill these attributes, and gives them the opportunity to select which ones. But as I said, the Toolbox does not currently have a UI to expose that functionality right now. Cool. So now I'd like to step through a couple more interesting scenarios when it comes to credentials and presentations. So we've issued this really basic credential. I should go to the credential issuance and look at it there, with just a name and an age to Bob with age of 42. So I'm going to add another schema and credential definition to the mix here. So going off of my employee cafeteria example from before, I'm going to go with employment credentialing. And at the same time as I'm typing this out, I'll also call out that schemas are separated objects from credential definitions for more than one reason, but one of those is reusability of schemas. So within a governance framework, it might already be well defined what attributes we expect to be presented in certain contexts. A machine-readable governance framework might include the schemas that we are willing to accept credentials from and accept presentations from. Man, that's really noisy, I'm sorry. So while I'm coming up with a new schema for employment, it is certainly possible and maybe even likely that within a certain legal jurisdiction, there's already a well-defined set, and instead of creating a new one, I should go and reuse one that's already available on the ledger. So I'm going to create one and say, I won't include name just for the sake of demonstration, but I'll say date of hire, and I'll add another attribute and say access level, I guess, if they've got a specific security clearance. What else should I include on here? I'll keep it simple and keep it to those two attributes for now. So I'll go ahead and create that schema, and then create a new credential definition from that schema. Again, takes a hot second as it performs that key generation in the background here. Also writes to the ledger, which is a not instantaneous process, I suppose. And there's our credential definition. And we see the attributes, date of hire, and access level. So we'll now go ahead and issue the credential to Bob using that employment cred def ID. This form is automatically populated with the attributes that we need to give as part of that credential definition. Add a comment here of proof of employment for the heck of it. And say date of hire is, I don't know, 2020, January 1st. Good question in the chat. Can you edit schemas or just create new ones with another version? And the answer that came back is correct. You would just create a new schema with a new version. So the schema will remain on the ledger and remain in use, and it kind of becomes a business policy decision to say whether you should be using one versus another, or a governance decision as well. And I'll continue with my credential issuance here, saying access level is basic. And our credential is now issued to Bob, at least from our perspective on Alice here. And we see the attributes that were issued are date of hire and access level basic. And if I go to my credentials on Bob, I see the new credential has been received from Alice and see those same attributes. I realize now I didn't explore at all previously what values are returned in this JSON structure here. So that might be of interest. You can see in the raw credential attribute, we see the schema ID and cred ID. We see the values with their encoded representations. And we see signatures that were used to sign those attributes. Honestly, couldn't tell you exactly what all of these different attributes are. That's above my head. But these are pretty well defined in the non-cred specification. And then there's a signature correctness proof as well. Let's see if there's anything else interesting to look at in this data structure. We've got the credential request metadata, which has a master secret associated with it. That's an interesting one. So I alluded to the concept of private holder binding previously. So in the non-creds credentialing system, there is a master secret associated with a holder of credentials. That master secret is blinded and presented to the issuer of the credential in order to issue a credential specifically bound to the owner of that secret. And this is what we use in order to say that this credential over here and this credential over here were both issued to the same individual. And this will actually be crucial in the next steps that we're going to go through in our verification process as a result of now having multiple credentials to present attributes from. So if I go to verification on Alice, and I'm going to create a new presentation request for Bob and say, proof for the employee discount in the cafeteria. Won't add a comment, I guess. I'll just leave it as simple as that. And then I'll say, give me your name and give me your date of hire. And it must be from this specific employment credential that I issued earlier. I can add that restriction, or otherwise it would be up to the holder of the credentials if they had another credential with a date of hire in it to swap it out for that one. So we want to add that restriction here. So then I go and hit confirm. And we see the proof pop up and we get the check mark, meaning that it verified as true and completed successfully. So we're able to see that Bob has a date of hire of January 1st, 2021, or 2020 rather, and his name is Bob. So we're good to go ahead and give him that employee discount for a sandwich. So we just use two different credentials, and as I was talking about, have strong guarantees that those were issued to the same individual. So it doesn't matter that they came from different credentials. We've got that cryptographic assurance taken care of. And if I can view the same presentation from the other side as well. So that's one interesting capability of the non-cred system that has been discussed in the W3C JSON LD credentials context, but has not yet come to fruition in any implementation that I'm aware of. As I mentioned, BBS Plus as a signature suite supports this sort of functionality. So in theory, using BBS Plus signatures and W3C credential format, you could accomplish a similar outcome. But the India non-creds has that all built in and is quite mature in its implementation of doing so. Let's do one more verification, or at least one more. Maybe I'll do another one after this. We'll see. So Bob, and now we're going to demonstrate predicate proofs here. So this time I will say, and Sam has clarified in the chat that BBS Plus allows for selective attribute disclosure, but does not have built into it predicate, the ability to do predicate proofs using zero knowledge proofs. Blinded holder binding, I'm not sure if that's actually accurate or not, Sam, but I'll defer to Sam on that one and say that he's probably right. Okay, so we're going to request a predicate proof from Bob for his age greater than or equal to 21, so that Bob can buy some age restricted product. I like that terminology that Scott was using earlier, so I'm going to steal that. And we're going to say that it's going to be a requirement to be from this credential as a stand-in for being perhaps a government issued ID from, you know, DMV as a driver's license or some other issuer that we're willing to trust to have verified that age accurately. We don't want it to be just any credential, as Shar was pointing out. We don't really care, honestly, if Dunkin' Donuts thinks you're above the age of 21. We want to know that the DMV or the government has gone through the vetting process of making sure you're above that age. So I'll hit confirm on that credential. And we see that it has also verified as true. We see the predicate of age greater than or equal to 21. And so we are comfortable going ahead with saying Bob is able to purchase this product or whatever. So there's a couple of questions that came up in the chat. Blinded holder binding and what is meant by that. So blinded holder binding is the process I just described in the India non-cred system, where there is a secret which is used to help correlate that two credentials were issued to the same individual. The blinded aspect of it being that that secret is never, of course, given out in its unblinded form to any other party because it's a secret. So it just helps with the ability to determine that scenario of two credentials to the same individual. I feel like I've repeated those same words multiple times, so if that didn't come out any more clearly, feel free to ask more clarifying questions in the chat and I'll give somebody else an opportunity to do a better job. If Alice weren't the issuer to, could restrictions show the credential definitions? That's a good question in the UI. So if Alice was not the original issuer of the credential, the UI is currently structured such that if we want to impose one of those restrictions, we need to know about the credit ID already. So in the Credential Issuance tab, and this is something we haven't used yet here, but there is a mechanism for retrieving. That's a schema. I need to go to this one. It's actually under My Credentials. Apologies for the bait and switch there. And we have the ability to retrieve a credential definition here. Probably not ideal placement in terms of UI, but if I go to indyscan, for example, and I grab the most recent schema, or rather CredDef, let's see, where, yeah, employment, that's one I just issued. Let's go with membership. And I go in here, and then I take the CredDef ID and then paste it in there and say retrieve. I haven't done this process recently, so I hope it works. It did, okay, good to know. So we see that it has the level and date. And then within the verification tab, we can, on requesting an attribute, we can use that CredDef ID. So that process that I just went through is more or less a manual discovery process for already out there credential definition IDs. I think it's more common that instead we would see those be included in a governance framework as being well-known values for a given credential, such as a driver's license credential from the government having jurisdiction in that whatever area you're in. So yeah, there's better systems than just using indyscan, but indyscan is a good analog for us to manually retrieve that data and use it in the toolbox. Let's see. I believe that about concludes all of the hands-on portion that we had planned for today, unless there are any more questions that people would like to have answered. I'll leave just a minute or two to see if anything comes in the chat. And thank you, Sam, for further clarification on the blinded holder binding. Okay, a couple of questions. Unfortunate scenario of Rocket Chat not working and couldn't establish connections between agents. Hopefully Rocket Chat works eventually, but you're also welcome to contact us at Indicio if you'd like some assistance working through these. We can provide some basic support at least and help you get through the demo on your own. Another question that came in here is mediation part working in the toolbox? That's an excellent question. So mediation. This was added to the toolbox at the same time as it was being developed for the Aries Cloud Agent Python code base. So these two sections allow us to request mediation from one of our connections from both the toolbox and the connected agent's perspective. So I could, using this tab, say request mediation from Alice. And if Alice was a mediator agent, then my toolbox instance would then start using Alice as the mediator of its connections. I'll be honest and say that I haven't tested this recently. So there might be some minor issues to resolve there, but last I checked, it was working. So hopefully it is still. The routing section here then allows us to, from a mediation client perspective, view which of our connections have mediation associated with them, which of our keys have we sent off to a mediator for mediation purposes. Oh, this is where we would actually request mediation from a connection. I misspoke earlier. Apologies for that. Mediation is a pretty detailed, I'll say, and nuanced interaction as well. We at Indicio have done trainings in the past on mediation before. We might have done a couple meetup events that might have recordings out there. Not sure. I'll have to check back and see if there's anything that we could share potentially there. There's also some documentation on mediation within the Aries Cloud Agent Python repository as well, where you can read up a little bit more on what capabilities are present and which capabilities are not. Let's see, which one down? So next one down is, so transaction ID equals credential definition ID. Let's go back to the indyscan and take a look here. So in this case, I'm not sure I'm 100% certain on this one. Lynn, do you think you could step in and help clarify this one? So is the transaction ID is the same as the cred def ID? Is that a universally the case thing, or is it possible for these two values to differ?
That is a good question. I am not 100% sure, but that's what it looks like to me right now. I can look that up and get back to you on that.
Cool. Yeah, that's my understanding as well. The transaction and the credential definition itself are closely tied as identifiers for that transaction. So that appears to be the case, but I can't say that I've got that knowledge in the forefront of my mind to say for sure. Let's see. Other questions? Can you give us some info about the mediator? Might come back to that. I did allude to some more resources there. Hopefully that is a good location to get some more info there. Can you walk through the parameters in the indyscan, please? I'm again not the expert on indyscan, so I'll let Lynn correct me at any point here. But these filters at the top here correspond to the transaction types that are possible on an Indy network. So NIM corresponds to the writing of a DID to the Indy network. NIM is kind of an antiquated term, originally was short for Verinim. So at Hyperledger Indy, as a decentralized identity solution that actually predates the W3C DID specification, uses some different terminology in a few different places. So NIM is DID rights. Attrib are more or less arbitrary metadata that you can associate with a NIM. This was a precursor to the DID document. again, given the historical background there, as it predated the did spec. Schema, of course, corresponds to schema transactions. Claim def, this again, bit of a historical context thing here too. Claims used to be referred to, or excuse me, credentials used to be referred to as claims. That was even persistent in the W3C space for a while before they switched to the term credential. Revocation registry definition is a definition of a revocation registry. This contains the remote URL for the Tails server that is responsible for hosting Tails files for recipients of revocable credentials. This is, again, kind of another can of worms that we don't really have time to get into today, so I'll leave it there for now. Revocation registry entry. I believe I used the term Delta to refer to this in a chat message previously. This is an update to a Tails file that is obtainable from a remote Tails server. So by taking the original Tails file and replaying all of the revocation registry entries, we get an updated list of what credential identifiers are within the set and whether they've been revoked or not. Again, that kind of gets into the weeds a little bit on revocation. Some more details can be found in the handout for links to info there. Set context, I'm not actually sure what that one is, so I couldn't tell you.
Not actually sure what that one is either, but I will add a little bit here. Over the course of our training today, the updates to indyscan have been as much as 15 minutes behind. And the reason for that is because indyscan has some settings in it that make it so that it doesn't cause DDoS or a lot of traffic on the ledger. It just pulls a couple of transactions at a time. And so it's been regularly updating throughout the course of people adding a bunch on, but it does get behind. I think it's about 4 minutes behind right now. It just kind of gradually updates itself and just a few transactions at a time. So apologies for it not being so quick, but that's because it doesn't, because we don't want it to have an impact on the response time of the ledger. So
cool, thanks, Lynn. There's been a little bit of back and forth in the chat. I think Sam's done a good job of addressing that one. And again, I think we're at a point where we should just be linking to some more resources for you as we wrap up here. On the topic of mediators, Indicio does run a public mediator that you can use for development purposes, kind of as a reduced barrier to entry for developing a mobile agent. I will obtain a link to that and drop it in the chat while we proceed on to our next section. So I'll turn it back to Shar, who's going to wrap us up, and then I think it'll go to Sam.
Okay. For the last section here, we want to talk about community engagement and how to get involved in the community, or both receive help and contribute effort to the things that are available. And so that's what I'm talking about in this final segment. And I realize that we're within 20 minutes of the end of the training. I will try to make this useful and brief as part of that. I'm talking about this because I've got a bunch of experience doing this. Daniel and I were both around before Aries was Aries. And so we've been involved there. I'm still a co-chair of the Hyperledger Aries working group here within Hyperledger. I'm also the co-chair of the DIF-DIDCOM working group, and I'll talk about that in a minute. This right here is the avatar that you'll see on all the places, and I'm Telegram Sam in most of them. And so if you see me on GitHub or on Twitter or something else, please reach out. I'm an architect for Indicio, and so I'm involved in addition to the community. I'm involved with lots of customers and helping guide them to appropriately apply the solutions that this space offers. Reasons to engage. There's a lot of reasons to engage, and I'm not going to read the slide here, but the The point that I want to mention is that there's various levels of engagement here. You can jump in to help. You can jump in. There's lots of people who join the community to kind of lurk and listen, and sometimes it's a long time or never before they either mention something in a meeting or comment on an issue, and that's okay. There's any level of engagement that you're comfortable with is the level of engagement that will work better for you. But engaging with the community is a great way to learn and to help and support. There's a handful of different organizations that relate to Aries. The most obvious one, of course, is the Hyperledger Foundation. That's where the Aries project is. We've also talked a lot about Indy, and we've engaged that in our examples today. Aries works with lots of ledgers and strives to work with even more, but Indy is one of them, and that's sort of historically what Aries was born out of. The other project to mention here is Hyperledger Ursa, which also came out of Indy and is a cryptography library that Aries and Indy both use, but is also spun out and available as a separate project. Hyperledger has been a fantastic place for these projects to live, and has been amazing in their support of the efforts that have gone into these projects. So very grateful there. Another organization to be aware of is the Decentralized Identity Foundation. They support a number of efforts. The DIDCOM working group is the one that I am the most involved with. In the Aries community, we developed what came to be known as DIDCOM V1, and there was enough interest from outside of the Aries project that we there's a lot of interest in other folks that wanted to be engaged with DIDCOM. And so we have been working for the last couple of years for the next version of DIDCOM V2 over there. And I expect this to be a great year for the progress and finalization of that spec itself. It's very similar, but some important changes that both improve the protocol generally and make it more usable by a larger community. There's other working groups there. There's an identifiers and discovery working group and a claims and credentials. Those all sound like very similar things. Sidetree is a technology that was organized there. And this can all be found at identity.foundation is where their site is and where you can find additional information. These working groups all have regular meetings and slides and all sorts of stuff like that. The Decentralized Identity Foundation does have a different membership model than Hyperledger, but for small companies or individuals, there's a streamlined process, which makes it easy to get involved. Another useful organization in the space is the Trust Over IP Foundation. Here is their logo and their URI. They've been done some really cool things. They focus on governance, and one of the projects they've been involved with is the Good Health Pass initiative. Linked here, and we'll have these slides later, is they have a really cool layer model of the trust layer that showed up in an earlier slide at the very beginning of our training today. And so that's worth exploring as well. They do a bunch of good work in that area. The W3C Communities Credentials Group. Can you see my slides? Sorry.
Yep.
Okay. So the W3C CCG is what it's commonly called. We've got some folks that can see them and some folks that can't. I apologize. I don't know what Zoom is doing. Well, I hope we can find a resolution to that.
I can see.
Okay. The CCG has been involved in two important things. One is the W3C credential format, and the other one is the DID core spec that, of course, we rely on. So the CCG is available there as well. So these are communities that you may want to get involved with, or that relate peripherally to the Aries work, and where you can find them. So when you engage with the community, often a bunch of the work is done in working groups. Working groups communicate typically via some sort of chat, like Slack or Rocket Chat. There's almost always an email list, and there are regular working group calls that you can join or listen to the recordings for. The calls this is very true of Hyperledger and also true of most other organizations. There's an antitrust policy and a code of conduct. I don't mean to imply that they only apply to the calls. They apply to all of the interactions of the working group. These groups are formed of people typically that represent companies, although sometimes individuals, that are in competition with each other and find that that it is worth engaging in standardizing and working together on some aspects of their business. So we call that co-opetition. So here's the basic rules. We don't discuss business deals. We don't discuss any sort of pricing in those calls, and just focus on the technology project itself. The code of conduct is also very important. Bill and Ted said it really well. We need to be excellent to each other. There's the code of conduct also contains policies and procedures to resolve any issues that do come up. And I'll have more to say about that in a minute. But calls are really common ways of doing that. They almost always have meeting agendas. Topics are, being the chair of several of these working groups, topics are almost always welcome, even if they can't be put on the schedule for the next week, or they'll almost always accepted. Meetings have different ways of sort of volunteering. Sometimes the Zoom hands feature or just speaking up is good. Sometimes with larger meetings, you need some more formal interactions. And so sometimes they use the chat as a formal cue so that you can sort of get in line to speak. And it's a great way to ask a comment if you don't understand, like how you ask permission to speak up, then dropping a note in the chat is an easy way to do that during a live meeting. The calendars are usually published by the organizations that host them. So Hyperledger has a calendar, for example, and the diff also has a calendar. Links are usually found in the repositories associated with the working groups or associated wikis or on the agenda. And a little bit of Googling turns these up pretty fast. The meetings are often recorded, which is super handy when you can't be available there. It's also really handy when you want to watch, if you watch in a player. VLC is one that usually will play the format that they're recorded in, and you can watch them in faster than real time, which is helpful when you need to catch up on meetings. They're usually posted. If you don't see where they are, then go ahead and ask, and that will help you with that. GitHub repositories are very commonly involved, whether they're code or whether there's other sorts of documents that are created. There's almost always a README that contains useful information. It's also worth being familiar with the issues in the repository, active pull requests, and you can also, of course, browse the commit history because it is a GitHub repository to see kind of what kinds of actions and who in the community is involved. You can contribute your code. There's a couple of quick tips here. You need to mind the code license that is in the repository to make sure that you understand it and that you are capable of committing that. You typically work on a fork of the repository and then submit a pull request for that. And the developer certificate of origin, DCO, you can Google that up for specifics as well, is commonly required for these repositories. And that helps with some legal issues surrounding the code. This is important, and I want to spend a minute on this. We need you in the community. We realize that everyone is busy, but if there's time or this lines up with the goals of your employer or personally, we would welcome your contribution here. I particularly invite you if everyone in the meeting that you join seems to come from a different background than you do. We need your perspective, we need your experience, we need you to help us understand things better and produce a better project. Please be persistent with your contributions. Sometimes there's rules that are a little bit frustrating about different types of reviews that are required or other things, but please be persistent with that. The general request here is that we're all human. The focus is on software, but we're all humans making it happen, and we all have different stresses in life, and not everyone is in a perfect place all the time. If someone is a little bit short with you, or a little bit impatient, or something, then please be a little bit patient with them and the stresses that they have. But here's the big but: don't put up with bad behavior. If there are things that are unacceptable, particularly because of the code of conduct of the community, that's not the type of thing that we ought to put up with. If there are things happening in meetings or comments being made or other sorts of things that make you feel unwelcome, please, I beg you, please engage and try to help us solve those issues before you leave. Obviously, this is fully voluntary. The These sorts of issues seem to be relatively rare, and I'm glad for that. But I want to make sure that anytime something does actually come up, that we improve our community rather than drive people away. We need you, and we hope that you will find the time, professionally or personally, to engage in the products or the projects that are important, that you're interacting with. The community happens because of volunteers and makes that work for it. And that's how we have great things like Aries as a project and Indy as a project, and all these other efforts that are happening in various organizations. So I hope that came across as a quick guideline and a plea to be involved. We are grateful that you're interested in this training at all, and that we're here. Again, this is me. This is a slightly better updated screen here. If I can help you with anything as it relates to the community or anything that we've talked about today, please do reach out. There's my email address at Indicio, or you can reach out on any of the other platforms that I'm engaged in. The same goes for all of the Indicio team. If there's a way that we can help, point you to resources, help you get past something, or know who to ask, please do reach out, and we would love to help you. We've heard from a bunch of really knowledgeable people today with all the things they presented. Daniel and Shar took a huge chunk of the technical presentation. Lynn did a fantastic job with the networks, and Scott with the introduction and the terms and the overview and the orientation to the concept. And so we're all available. James has his email that he's just reached in the chat, and you can reach all of us. We're glad you came, and we hope that you learned stuff today and that this was useful. And we're glad that you were here.